have any light at all in Alaska at certain places, which kind of
Right.
doesn't work.
All right, so we're live now. I'm back with Michael Gillis, and we had a good conversation earlier today, and now we're like addicts. So
Yeah, right.
uh,
Absolutely. No,
we're
I
back,
like
and
this.
I labeled this video "What is tangible," not necessarily what we're talking about. It's just I needed a title for the video. So, but we were talking about that earlier. I got some kind of fruit fly or something in here. What is tangible? What can we actually test and prove for ourselves? I think that's an important thing to do. Instead of just taking somebody else's word for it, or just accepting what we're told. And of course, there's things that we can't even test that we can also like agree on, right? Like there's certain things that we can agree on, regardless of the model, and that we can't even test for ourselves. And those are things that we consider as well. So I'm gonna play this video from Joe Hamby, and it doesn't describe his model or anything that he's made. And if you get on his webpage, you can also look at it. He talks through. I'm gonna see. I don't know if it's gonna play the sound because it has to go like through the speaker and then to the microphone. I don't know if it's doing that. So I'm gonna add that, and all it's going to show is how you can see the counterclockwise rotation of the stars. But he explains it in the video, and I don't think it's going to play the sound in that. So
All
we'll
right.
see how it goes.
So that's how I got northern
Oh, no, I
and
hear it.
southern star trails to work.
Okay.
Just by projecting rotating star into the dome and figuring out the counterclockwise 24-hour Antarctic sun is what allowed me to figure this out. So the rotation of the crux around Sigma Octantis is absolutely possible on the flat Earth. Star trails in the north and star trails in the south, no matter where you're at in the south, you would see that rotation of clockwise stars.
So do you see that?
So yeah, I can kind of see it. I mean,
It's,
where
you
is
can
our
kind of see like
perspective supposed to be from right here, though?
yeah, and he
So,
doesn't
like,
explain that in the video there, but anyway, I was just pointing out that the model that he's working on and that he's been working on for a few years, uh, as he's developing it, it's
mhm.
he's able to do more and more as he's developing it, and he's trying to do more with it. And that's the kind of thing I wish I had time for, is like being able to present something instead of just talking about it. But
No,
I don't have
100%. I
that.
mean, and
I
that's
don't
what
have
it
that.
takes,
So
right? That's what it
right,
takes to get the proof, is like to do something. Like I was talking about earlier, is with the things that people have, done or haven't done, but it takes a lot of funds and it
right,
takes a lot of manpower to do
yeah,
these
yeah,
things. So they are doable. We can go build a rocket, and I know I bring him up again, but Musk is an example of that. He is not a government institution. He is his own person. It's a privately funded space company. I'm pretty sure he was the first. There was that poor guy, man, rest in peace, that wanted to see the Earth. He wanted to see it flat. I think he was from Nevada. I forget, man, but he shot himself up.
oh,
I think he did it once or twice before,
uh,
and then the final time he died.
yeah, yeah. He wasn't
He wasn't. I'm sorry. You
that
cut
guy,
out.
Mike, Mike was not a flat earther.
No,
The guy that died no, he
in the
wasn't. He wasn't a
rocket.
flat earther.
I
Yeah,
could have
that's
swore that. Well, then I'm. Yeah, I guess I haven't done the most
it's
research on it, but I remember he's talking to the camera like, I think it's flat. I want to see myself.
no, I know. If we're talking about the same guy, and I think we are, he wasn't actually a flat earther, but he was being. I think he was being sponsored by some flat earthers. I think.
But he
But yeah,
died
yeah,
nonetheless.
he had that. I mean, it's cool. I was always intrigued with rocketry flight. I remember as a kid, I used to get all the popular science and popular mechanics
Yep, absolutely.
books that I could get my
Same.
hands on, so I could like, oh, that's cool stuff, you know.
Yeah, 100%. No, absolutely. I get it.
Have you ever heard of the Rayleigh scattering?
I don't think so.
Rayleigh scattering is like how light travels through densities and fluids and different things like that. It would be something interesting to look into. Is
Yeah, so because that is similar to why way back when people were trying to figure out not necessarily the speed of light, but the speed of light through a vacuum or the ether, is they didn't think light could travel through nothing. They thought there had to be something for it to travel through. And Michelson Morley
yeah.
did all that.
So that's a good thing to look into, is the Rayleigh scattering, and he actually has a video as well that he did, Joe, on his channel, and you can check that out. It's just something that I find interesting, because when you get into like light dispersion and things like that, all those things have an effect on our radiation. So you have an observation of like earlier, the observation of the moon,
Mhm.
but how do things be the moon is and everything else, how can we see things and all that. It's part of the nation. So I was talking to a guy, and we were talking about the he was trying to use as proof for the globe Earth as well, and saying the shadow, the shadow, we're talking about lunar eclipses, and he kept
Yeah.
saying, the shadow of the Earth on the moon, the shadow of the Earth on the moon. And I was like, well, that's part of the narrative, because you can't actually observe, me and you and him, without a spacey type of thing, we can't observe the actual sun, the Earth between the sun and the moon. We can't actually observe that, but we can observe other things. And so I was just trying to get him to get away from the wording of the shadow, as opposed to the dark area on the moon.
So
You can
what would it
rephrase it
be
so
then?
it's not used as the narrative.
What would
Well,
it be
like the
then
dark
if
area.
not the shadow? So I know it's not always the shadow. We don't always see it. Lunar eclipses don't happen like frequently, but when we do see half of a moon, well, that's because it is a sphere, and that's why you can see it during the daytime too, because of the angle of it, and the sun's hitting it, and we're only seeing half of the moon because the side we're seeing half that's lit up and the half that's not, and it almost puts a straight line like right
Sure,
down the
right.
middle of the moon.
So the point that I was making, though, was it was just to get him away from using the terminology and just change his terminology. And he wouldn't even he got so kind of upset at me saying the narrative that you're using, because you can't validate that it's the actual shadow. And I was trying to get him to validate it. Like, if you're saying shadow, then validate it, show how it is the shadow, and not just say it's the shadow, right? So
Mhm.
it makes it into like the category of non-tangible things. Okay, you have an observation, there's a dark part, dark part of the moon, you know,
Yeah.
but if you're just going to say it's the shadow of the Earth without validation, then you're just saying words. You're not really actually validating your claim, and he didn't really care for that, so he stopped
No, and I
engaging
get that,
with
and
him.
it's hard for us as just average people to, hey, I haven't been there, or Buzz Aldrin and everybody else, they're all actors and stuff. But I mean, I get it, because
Right.
I originally wanted that tangible evidence myself.
Yeah.
It's a trust thing, and I don't trust people, especially like I was talking about earlier, people in palette. But it goes both ways then, because if you're willing
Yeah.
to take and accept that CIA document that's saying firmament, and you believe that they were testing the firmament, but then you disregard everything else that they're saying, like that.
Right. So yeah. So again, and that's why I say, and a lot of people say, go back to what is actually tangible, what you can actually, observe and test and measure and validate yourself. Go back to those things. So
Yeah,
if we can get away from like, oh, we can't do it ourselves anyway. So let's focus on what we can. Now, Joe, in his videos, he's of course, he's using the assumption of the firmament, right? He's using the
Yeah.
assumption, and he's showing how it works with that assumption, right? And that's okay to do. And that's what I was telling him to do. I was like, this other guy, I was like, show me how you're using that. How you're coming to the conclusion of it's an actual shadow and not just a lighting of the moon. And it doesn't matter. I was like, if you don't want to engage in a conversation, you just want it to be one way. And I wasn't even presenting anything. I was just asking him questions like, how do you validate that it's the actual shadow? And he's like, oh, you have to accept it because it's widely known. I was like, no, I don't have to accept anything, right?
Yeah, absolutely. I mean, religion's widely
Like you
known
said,
and all that stuff, but that doesn't mean it's true, Like I
right.
100%, I get it.
Yeah. So, and I'm not just going to accept something because
Someone told you, as you shouldn't.
Yeah, right. Like you said earlier, you're at the Boston airport. I could accept that, or I could look around and do some investigation and validate that.
True. I mean, and I can always just be streaming shit in the background. Oh, sorry. Try to watch my language. Streaming stuff in the
Yeah.
background that's not real. I mean,
Right. Like I say, I'm in Fairbanks, Alaska, right? And you could say,
Yeah.
oh yeah, he's in Fairbanks, but you don't know that. I could be in Florida.
100%.
I'm not. I wish I was in Florida.
No, shit. I'm sure because the cold, I don't really agree with it
Right,
either. Even up here in
but
Boston.
even like but there it would take a little bit of time to validate that I'm actually in Fairbanks. I could show you different things. I could go outside. I could present. I could show you the welcome to Fairbanks sign. That's tangible, right?
Yeah. You could have placed that there.
Or it's just hearsay, right? Basically, oh yeah, I live in Fairbanks, Alaska.
Yeah, and you could have had it planned all along. And
Right,
you're
yeah.
not, and you're in Georgia or something. So it's like, where's
Right.
the line? And then
Yeah.
if there is no like, how do I put this? Like the negative, like, okay, so my question earlier was like, why the lie? Why the lie? Also, if
Right.
it is a lie and it is the truth, why keep pushing it? Why not stick with, we went to the moon, we're done, we ain't going back. Why the Hubble? Why discover satellites? Why
Right.
all these things? Like, that is
Yeah.
my
So
big thing.
no, and I know that's a hard thing to like comprehend, and for me and for a lot of people, I would say because it's a spiritual warfare thing as opposed to like a physical thing, so
Yeah.
and
Okay.
I don't
about
go
spirituality.
into I don't go into like the scriptural biblical aspect with people if that's not what we're talking about. But for me, I see there's a spiritual aspect to it of why, right? And some people say like they're hiding God, they're hiding more land, their control. And I think there's a lot of reasons. But so if we stay, let's say all of our conversations, let's say we agree that we're going to stay away from, like the biblical aspect of this, right? If we agree on that,
I mean, that's
and
fine with me.
then what I would do is I wouldn't bring it up, like I wouldn't bring up anything about the Bible if somebody doesn't want to talk about that. But if somebody's like, why do you think the firmament exists? I would start from the biblical aspect, like, okay, this is what it says in the Bible, and this is how we can show things, right? But
Yeah.
I can't test again. I can't test the firmament myself, so I don't have a test. But like Joe does, he shows how it works with the firmament, with the dome, right? So that's part of the flat Earth model is it has a so, and he shows, and that's why I like his work, because he's showing how it actually works with the firmament. So
yeah, another
to
possibility.
say, right, yeah. So it's, and this is not going to this may not persuade anybody, right? His demonstrations, but it's an actual demonstration, So what it does do is it eliminates that whole, it can only work on a globe. That's what it does.
Yeah, and so I'm gonna have to go back and rewatch this video too, because It was hard for me to see on my phone screen. I put it on my laptop, but it wasn't like working
Yeah,
right.
yeah,
So I'm gonna have to
yeah.
go
Even
back.
the one that I was watching, that I played, I was watching it on my phone. I was like, man, I can't hardly see it, but I can
Yeah.
see it a lot better on my screen on the computer.
Fine.
So I would really like to talk about like what is something tangible, you know? So and I think that's a big thing. So anything for me, anything in the sky is not tangible because I can't measure the distance. I can't physically measure the distance to it.
Yeah.
Excuse me.
Well, we
So
can. Hold on. One second. Because we do have what is it? The cops use them all the time, the speed guns. Like there are ways to use radio waves and light waves and stuff that bounce back. That radar in itself is a wave bouncing off of something. That's another issue I have too. With my roommate came home, so I had to step out of my room. I didn't want to talk while he's in there.
oh yeah.
But like we do have ways to measure the distance of things and things that are very far, just like stars, the angle and the shift of light from when the parallax, like that we can measure throughout the year of moving around our star. Like that's, and I did just recently share a
Well,
whole
sure,
video on that
we can
too.
measure we can measure the angle of the the traverse of the sun going across the sky. We can measure that from our position, but it can be anywhere in that in that angle of view, right? Like
Yeah,
the
but the
sun
sun
can
also
traverse
doesn't
out
change
here
size.
or
The
it can
angular
traverse
size
out here.
doesn't change. The
Right.
angular size of the sun never changes. So that's one reason why it's like it doesn't move like the flat Earth model suggests.
Yeah, I
Because
think
otherwise it gets smaller, right?
I don't think so. I think there's different aspects of why, and that's part of Rayleigh scattering and have you heard of the man, I can't law of light. It's I'm having a brain cramp right now.
No, it's all right. It happens.
But part of Rayleigh scattering and
So this is like all right, I don't know if you can see it on
that's
the
a laser.
screen. Yeah. I mean, $20 on Amazon, and I haven't done anything with it yet, but it's like I'd have to get somewhere that's obviously level, same size, but that's what they did on that darn movie where they tried measuring the curve over a distance. And I understand that movies can be cut to go against like really what they were saying.
Right.
It can really obscure what's really happening, the way people cut films and stuff. So I get that. I'm not gonna hold that against them. But just little things like this that I'm holding in my hand, and there are many other tools that you can buy, telescopes, all these things that do truly measure the distance between yourself and something you're looking at.
Right.
I'm trying to.
But when we start with it all depends on our starting point too. So if our starting point is something that's not right, then our conclusion is even if all the steps in between match.
What do you mean by starting point? Like,
well, again, that's why I say prove the assumption of the globe, because if you can't go off the if you just use the assumption and then you use everything that's given in the assumption to show that, you're not proving the assumption, right? So either the assumption flat Earth or the assumption of the globe, how do we validate
you
either
start
one?
with
So
one. Yeah, you start with one, and okay, so there are many different things that would have gone differently had the Earth been flat and the sun been local to measure the shadows between Alexandria and Siam or Siam, wherever he
well,
did it
right.
first.
Yeah, so even even Neil deGrasse Tyson had that Eratosthenes' experiment works on a flat Earth as well with a local sun. So it
with
doesn't
the local sun.
validate.
Yes.
It doesn't prove the assumption, right? Because that same experiment and you can use the same math on a flat table to get a spherical table or a curved table.
Yeah.
Because you're
Yes, but
just
see,
using
the
math
local sun would
as
have
opposed to
many other different things to it too. It wouldn't behave the way our sun behaves. That's it. It would work with local sun, sure, but the sun wouldn't set then over the horizon. It wouldn't disappear on a not a flat. See that, and I have trouble grasping that too. Like, there's no way if the sun's constantly
right.
overhead, would
So
it ever look like it's in clouds?
the sun does appear in clouds.
Like, all the videos I've seen, like, oh look, there's clouds passing behind the sun or something. I don't know. I see them all the time, and I'm just like, no, it's just the different thickness of the clouds that some of them are easier to see, so some of them are not. So it creates kind of like an optical illusion.
Oh, right. Again, so we're talking, and that's the thing, right? Is talking about optically or tangibly, right? So I can measure the distance from my house to the end of my road, tangible, right?
Yeah. Yes.
I can see optically. I can see, from my not from my house because I got trees around, but like if I was to go above my house, I can see 30 miles away without even any kind of lensing. I can see.
Yeah.
And so optically, the sun does. We don't understand it. We only know what we're told. But if we're leaving all that aside and we're just doing the tangible experiments for ourselves, we come up with different things than what we're told. Like for instance, how the sun works and how we're able to see it and different things like that. Like, here's the thing, right? You can see the sun any day of the year. You can see the sun, and it's all bright, and everything is lit up and everything, right? Well, as soon as the sun goes past a small little cloud, now it's not bright anymore. So the a cloud can block out the sun, but it's traveled 93 million miles to get to us, and nothing's blocking its way.
Well, yeah, because space is very, very vast and very, very empty.
Well,
and sometimes something does block it. Sometimes something does block it, which is the moon, which we just saw like a couple months ago, I think it was. There's a whole big thing around here too. I'm sure, actually, I guess in Alaska, I don't think you were able to see it, but we got like a pretty close to a full-on eclipse up here in Boston.
Right. But what I'm saying,
I don't understand how that works on the flat Earth. The eclipses.
Yeah. So what I'm saying is, like, what can we tangibly do ourselves? Forget all the space stuff and everything that we're told about, what's going on in space and vacuum and all this other stuff. What can we actually measure for ourselves? And so I can physically measure, if I'm at an elevate, let's say I'm at an elevation of like 650 feet or whatever, and I can actually see something 70 miles away, right? But the curvature of the Earth that should be there should be blocking that entirely, right? Whatever the thing is.
Yeah, but that's not the case though, because I've watched ships disappear over the horizon. Like, I've seen it happen. Like, personally, not like videos, like, like when I went to the shore.
No, I know.
I've seen these things disappear.
And then you can bring those back into focus.
No, because this has been with the little things you put the quarters into and you look out, it gives you the whole big.
No, I know, but those don't zoom in any further. They're just at that position. So there's this in Georgia, it's called Lookout Mountain. Have you ever been down there?
No.
Okay. Anyway, it's a climb that you can see 7 states at the same time. Well, we were there, right?
7 states.
I went to Lookout Mountain in Georgia, have any kind of zoom lens or anything. I just have my phone and those, those binocular things that you're talking about. You put the quarters in. That's why
Yeah.
I thought of that. So and you could see in those binoculars what they claimed, but you can only see so far still because their zoom on those are limited. You know what I'm saying?
Yes, but if that's the case, then we would have had from an extremely high point, we would have seen, across the pond over to Europe.
Oh, but
Because you
what
can't
I was getting
have,
at,
even if the moon is local, even if the moon's local, it's still far. So it's still farther than any other country would be, right? Even if the moon's
Yeah,
local, I'm
I
not sitting here
understand what
saying
you're
it's in
saying.
orbit.
Yeah.
It's low, so it's far away, and we can still see it. But then why can't? And because the excuse I always get is, well, we just can't see that far. But we obviously
Well,
can
so
because see, like,
again, the lights, like the sun and the moon and the stars, they're going to be different than looking at a mountain or a hill or something because it's it's a light source and not a I don't want to say physical
one of them's
object,
a
but
light
it's not like,
source.
well, I mean that's another topic on the moon, right? And that's why I asked like earlier, what do we want to
But
talk
that is
about the moon
tangible.
so we
That
can.
that's definitely tangible, though, to know that it's not a light source because not all of it's lit up all the time. We were just like, because there's a shadow, so it's not its own light. We know. I mean, we know. So to say I don't
Yeah,
know it's
I
not its
would
own light
say,
source is getting deep into like, well, how do I know reality's real at this point? Or because that's where it gets, because all these things are tangible that we can do ourselves if we were so inclined to go watch ships go over the horizon. And me personally have only ever seen it different if it's from a video with somebody else, which is the same as me bringing up NASA and their footage.
right,
That's why I
I
try
would
to
say
stick with things like viewing the moon and the constellations. And I do want to watch this video again, like when I can see it either on my phone, because it's hard for me to zoom in here like the way it is on my phone. Because I still don't see how people can see the Southern Cross rotate clockwise from South Africa, South America, New Zealand, Australia, all that, but then travel
right.
north.
Here's this thing I was talking about in Georgia.
Oh, okay, to see the seven states. I gotcha.
Yeah.
Goes back to the mid 19th century when people started to promote the
So
scenic view. Sorry, that's
yeah,
probably loud.
so I was here, and again, I only have my phone with me, but these little half mile thing, that's irrelevant. So what you can do is know what's out here. All right, what's all out in seven states land out here, right?
Yeah,
Lookout
and that's
Mountain.
what they tell you.
No, I've been to these places. Like it says, Tennessee. I've been to all these locations actually. So like I can look out, let's say in this direction here, I can look out in that direction, and I know that there's something out there because I physically was there. It's tangible, right?
Yes. Yeah.
Let's say it's a barn, right? And back in the 60s, I think it was, the people that built this Rock Mountain and all this Rock City and all this, they went and put advertisements on barns out in different locations for kind
That way
of
you
for
could see
advertising.
them from up there.
Yeah, you can
Is that
see
what you're
those
saying? Yeah.
buildings from up there, right? And it's
Yeah.
60 miles away or whatever. And I know that I can measure that, right? And then you take the what the curvature of the Earth would be between here and
And
here.
your altitude and the altitude of the things you're seeing.
Yeah, you add your altitude in, and then it's still that building or whatever you're looking at should be blocked by 600 feet of physical curvature of the Earth. Well, I can see it, right? So that's to me, that's something tangible that I can actually physically do.
Yeah, but
And I've done.
we would need to check the math on that 100%. Like we would need to
No, yeah,
lay out
I'm
the
just
actual
I'm just throwing things out right now,
yeah.
just for conversation.
Because
But
then we get to math and it's like, okay, I'm no math whiz. I can do algebra, you know, I get it to a certain extent.
well, yeah, but you don't even have to do the math. There's enough calculators online that you can go to.
But so you're
what I'm
believing the
saying,
calculators. So yeah, I guess how do you pick and choose what to trust?
yeah, sure. I mean, what I do with the calculators is and these are promoted
I
and
know the
made
Earth
by,
curve calculator, but they're not have nothing to do with the flat Earth. No, I'm aware. It's like I
they're
remember looking it
globe
up
things.
myself one time too.
Right. So they're globe tools, right? And so and there's ones that are better than others, and but there's generally, so like if one calculator says, oh, hidden should be 126 feet hidden or whatever, and then another one says, oh, it should be 140 feet hidden, I go to multiple ones to see what they say, and if there's some that
Yeah.
are close, I'm going to take kind of the average, or even go into the higher one, or the more beneficial one towards the globe. And this is why I say I go to tangible things. This is tangible. I can physically go here. I have physically gone here, and I can physically drive to these different whatever location, right? I-24 or whatever. I've actually been to those locations, and so I've been up here on this Lookout Mountain with just the binocular thingies that they have up there, over here to the left and right, and I've seen things that like you shouldn't be able to see, because even though you have between here and out here, you have, you're at an elevation of 1,700 feet, I think it is something, and you can look into all that.
Yeah.
But even with your elevation of 1,700 feet or 1,900 feet or whatever you put in, you can calculate what the globe curvature would be, right? So if something is like 70 miles away and you're at like 1,700 feet, your horizon to the globe, the physical horizon to the globe, would only be 50 miles away. Okay. At like 1,700 feet. So if I'm seeing something at 70 miles away, that's telling me that there is no curvature between
Or that it's whatever you're seeing is higher than the horizon. Because if your horizon's 50 miles, then that's at the point. If that's where you can see from your point, then that's at the point where anything like 0 inches behind it is visible. But as soon as you get things that are taller, a couple feet, a couple yards high, then that becomes more visible over that 50 yards. So, and if it's something with significant height,
but I'm not talking about things that are higher in elevation. They're lower in elevation to where I'm at, and I can still see them. So like the curvature of the Earth, right, is a physical block, right? But that stuff should be lower. It should be lower than that, but it's higher because I can see it. So it's not higher. It's still lower regardless, right?
That's something I'd rather do more research into, because like as far as the math behind it, because just 70 miles and 25,000 miles, or what they say we are, 25,000 miles in circumference.
Sure, yeah.
I mean, this is why things appear to look flat, because of how big that is. So let me ask you a question though. What was it for you that was like, oh shit, this is it, I don't believe the globe anymore? Or did you ever?
So for me, the way I got started into this, and I don't know if you got the thing, I accepted your friend request, and so I do videos on what the how the scripture lays out creation. And anyway, to answer your question, what got me was the firmament. I was not looking into flat Earth. I was not looking at any of that. Right. What I was doing was I was at work in the Army, and one day I was just watching YouTube videos because I was bored, and I needed to pass time, and I wasn't actually doing the work I was supposed to be doing, paperwork. So I was watching. What I can remember is I was watching prank videos, right? Like just for laugh videos.
Yeah.
And so they had a prank video that was they were shooting a rocket up, getting people to believe that they tied their cat or something to a rocket,
okay.
Right. And anyway, back in 2016, 2017 era, if you watched a video on whatever, the algorithm for YouTube would feed you the next video that was similar to that. So I was watching a bunch of videos on just for laughs.
I mean, that still happens for me.
Videos. But then I started watching that rocket video, and if you watch something like 3 times, it starts cueing that
feeding you,
thing.
Yeah.
Right. Yep. Yeah. So if you're a Chevy guy and you're looking like, oh, what do I need to do to replace my, valve cover on Chevys? The next thing you're going to get is 100 Chevy videos, right? The same thing.
Yeah.
So anyway, back in 2016, this video popped up. It was called, and I didn't care about flat Earth. I didn't care about anything like that. But it was a rocket video, and it was the GoPro. It was the not the GoPro, but it was the amateur rocket.
Oh, the amateur highest one where they put the D-roll on it.
Yeah, and but the title, and I said this stupid video. YouTubers are so stupid. They make up anything they want, right? But the title was "Amateur Rocket Hits the Dome Firmament Over the Flat Earth," and I was like, "Flat Earth? That's stupid. That's a stupid video, idiots. And then the firmament. I was like, I know what the firmament is. That's a Bible word, right? That's a Bible word. So I thought I knew what that was. So what I did was how I started off looking into it. I was like, the firmament, that's stupid. I was taught that the firmament was the ice canopy that was around the earth, and we don't need this 7 states anymore, do we?
No, that's fine. Yeah, good. Yeah.
But anyway, so I'm like, okay, I know what the firmament is. It's this ice canopy that surrounded the earth, and during the flood of Noah, it broke apart, and now there's no more firmament, because that's what I was taught, right?
Yeah.
And so I was teaching college and career Sunday school class at the time. And and I'm teaching them like, hey, you need to dive more into what you believe. Don't just take my word for what you believe. Don't believe other people like the pastor of the church or whatever. You need to know what you believe and why, right? And so anyway, I'm teaching them this, and I'm getting into like, you need to really dig into what you believe, and don't just take my word for it. So then I get this video, and I'm like, man, I need to dig into what I believe about this. And so scripturally, biblically, the earth is spread out flat with an enclosure, the firmament, right? And that's not even a debate, really.
Well, no, because it doesn't say it's flat.
Yeah, it does. And I would show, but that's the biblical conversation. And if we're just talking about tangible things that we can test and prove ourselves, then we'll stay away from that. But I was just telling you how I
would also just, the one thing I would say on that is, even when someone translates something like Spanish to English, a lot of things turn out differently. So imagine translating Aramaic and like all that old stuff into the, so, and I get it, but anyway.
That's what got me going, is because I was like, well, that's dumb, because I know what that is. And then I went back to scripture, and I looked at it, and I was like, well, that's not what it is from the scripture standpoint. So all I did was started looking into the scripture and stuff. And then I started looking at like the physical aspects of it, because I'm talking to people about how this is what I would ask some of my students is the Bible enough? Is the Bible enough for somebody that you talk to? And it's not. Because people will say, I don't believe the Bible because it's circular reasoning. You can't say the Bible is true because the Bible says it's true. So I was like, okay, let's find out what is physical, right? What we can actually physically look at ourselves. Well, that kind of leaves out the firmament, right?
Yep, because you
So
can't.
then I just started looking at the physical aspects, and this, like this was one of the big physical aspects that really got me in the actually proving the flat Earth or not. Right, is how far I can physically test this stuff myself, and so that's what got me like looking deeper into the physical aspect of it as opposed to like the biblical aspect, right? And so
Yeah.
so you could go into if somebody wanted to have a conversation about like the biblical aspect, and then we just look at what Scripture says, it doesn't. There's nowhere in Scripture that references a globe, ball, Earth, or anything like that. But again, that's not for everybody, right?
Yeah,
So
because to me, in my
then
opinion,
I
the
have to
Bible and Scripture is a spiritual. It's for
right.
spiritual growth. It's not
So
for
so uh
factual.
so I want to be able to present something in a way that somebody like you that doesn't necessarily hold to the Bible, that we can still have a conversation about, right? And so
Yeah.
then I got this whole physical thing, like, and the using the scientific method, right?
Mhm.
Prove the assumption of the globe without using the narrative, right? So if we say anything that we can't verify ourselves is just narrative, right? Because we can't verify it ourselves. Like I tell you, okay, the firmament is true because the Bible says it. That's not tangible, right?
No,
So you're not going to take that as empirical evidence because the Bible says it, right? There has
of
to be
course not.
something physical, right? All right, so that's what I if you want to, if somebody wants to talk Bible, then let's do that. But if you want to talk physical, tangible, measurable, testable, repeatable,
In order
demonstratable
to
things.
in order to do that, though, there has to be because most scientific studies and theories are they when you break it down, it's really simple. It all comes back to just basic math and basic biology, basic chemistry, how things interact with one another.
Well,
But
we
at
could
a
say
certain
the
level,
math.
you have to understand like how things work. All right, here's one I'm gonna bring up. Gravity. What why do things fall?
Well, right. And if we're using, let's say, so there's like three main kind of gravity theories. One is the general sense of gravity; things fall, right? The other one is Newtonian gravity, and the other one is Einsteinian gravity, right?
Well, there
So
are those two are they are almost the same. The only difference between Newtonian like gravity and Einstein's theory of relativity is things that are very, very, very large, like very massive. But
yeah,
everything else, like Newtonian gravity, gets us our orbits. It gets us
well,
the rings around Saturn. It explains
right, but
all of
it's
that.
just, and again, it's just a theory because you can't demonstrate the Earth attracting mass. You have to have the size. You have to have the size of the Earth, the size of the Moon that they say it is, in order for that to even work. But I want to get to the point of what is the actual size, and nobody does that. Nobody gets the
Well, the
actual
size
size.
of
It's
Earth.
only what we're told. Yeah.
Yeah, but so okay, if you wanted to know the size right now, let's just if hypothetically you accept that it's a globe, what would you do to prove the size of it right this second?
So that's what I try. That's what I did tangibly. I tried to do that tangibly. So if I
No, no.
accept that,
So not you're talking about the seeing too far thing. Is that what
uh,
you're? I mean, like to measure the size of the globe, what would you do right like now if you're not gonna trying to think of like a good example here? Like, uh, it's kind of difficult. Like, you're not gonna tell an electrician, I don't know, depending, or you're not gonna let somebody that knows nothing about gold mining tell you how to do your job because you've been doing this your whole life. And also, that's another thing where gold comes from inside of stars and all that. I guess we'll get to there eventually, but
well, none of that. Again, that is not provable, right? You can't prove to me
so,
that gold comes from stars.
but it is though. It is because we can see the different light from different nebulas and the atoms and all the things that are being made. We know how the sun works. We know it's doing nuclear fusion, like
No,
right now.
no, that's all. That's not provable. That's not testable. Think
We
about this
just
too.
had the wait. You got to see the auroras where you're at,
Oh, absolutely. Auroras are
and what
electromagnetic.
100%, which comes from what our magnetic field that the Earth is creating, which is also in the south. They have southern lights
Uh,
as well because that's where the poles are from our core
well,
spinning.
right. So that's again, and this is what I'm trying to point out is you say poles, meaning that there's a north and south pole, but that's an assumption based
It's well,
already
no,
on the pole.
because like I'll have to go back to that video and really watch to see if he explains it well. But it's more than an assumption because the constellations, because of the way they spin it. When you get down to the very tip, just like when you get up to the very tip and you're looking at Polaris, and you put a time lapse camera up there, you are rotating one way, and when you go down to the very bottom, you are rotating another way. It's the same way, but because your perspective is different, you're seeing it another way.
All right. So again, that's
Same thing with the
you know
face of the moon.
You can look at the stars though and say this and that, but it doesn't show you the rate of curvature for the Earth.
You're right, but you're absolutely right. It might not show us the rate of curvature, but it does show us that we are not on a disk, that we are looking beneath us. And you can also see this by just traveling up and down. You take a boat and you go up, you will slowly see the constellations start to change. And then when you go back north, they all come back into view over the horizon. So one of my biggest questions to people that believe in the firmament is if you can't deny watching time lapses of the night
Well,
sky, even when you look at the
Star Trails, yeah.
even when you look at it, they go underneath, they go under. And a lot of them, if you're at the equator, it's going up and around. It's coming behind, like obviously it takes a while, 24 hours, but it comes around you. So is the dome a circle around the flat earth and the stars are on this dome? How are
Right.
they doing that? How are they all dipping
So
below?
again, that would be that would be speculation because we don't have the technology and the capability to actually test the structure itself. If the firmament, if we're claiming the firmament and we can actually test it for ourselves, like we can actually physically test what it is and all that stuff. If we're actually allowed to do that, then we might have better answers. But
Well, you can't prove we're not allowed to
speculations.
do that.
What do you mean? I can't.
You can't
Go
prove
up
we're
and,
not allowed to do that. You can chill.
no, I'm saying
And
I can't. I can't do it, right?
you could do whatever you
And you're
want
not
with
gonna have.
enough resources.
Yeah, but I don't.
I know. Trust me. I wish I had the resources too. You kidding me? And don't get look. So when I tell you I originally got into this because like I was, skeptical. I consider myself a skeptic, but I have to be skeptical of that side too. That's okay.
Oh yeah,
I believe it's a
yeah,
globe, but I have to be
absolutely, yeah,
skeptical of that as well.
yeah,
And I
absolutely.
can't just accept
What?
something, which is why I kind of like the testing of stuff. Like
Right. Yeah. So that's what I'm saying is that's what we should be doing is we should be actually testing something and not just
yes.
taking somebody's word for it. So like
No, but
again, I can't test
science
the
is
firmament.
jumping off the backs of others because they have done the work. I'm able to hold this phone in my hand and I don't have to build it from scratch with raw elements because somebody has started from a fat old
Oh yeah,
suitcase cell phone.
right. But that's the argument of you reject all science. No, we don't. Nobody rejects all science. We reject the pseudoscience that can't be proven. Our phones, our technology is a science that is tangible because it's in our hands, right? And that's what I'm trying to get to is like it doesn't all the speculation doesn't matter. Speculation on either side doesn't matter. Okay, it doesn't matter if I speculate that there's a firmament. I can only show how it would work if there's a firmament, right?
Yeah.
All right, so then it eliminates it falsifies the only globe work. It only works on a globe.
But
So I
I
can't.
have yet to see, like I said, I haven't seen his Star Trail thing. It's just very hard for me to see on my screen. So I have yet to see
Yeah.
something that works.
Yeah, look at.
If I am so
Just
open
take
to
some
it, I would
time.
love to
Go
say
through
God
his
created
videos.
this little thing for me, and I know for sure that there is an afterlife. Coming from someone who has been, that's it. I would love to know for sure this is all just for me. You know what I'm saying? Like, and
Yeah.
I would accept that.
Right.
But
And
everything points to the contrary.
what I was wondering about this. What would it take to change your mind? Not just about flat Earth, but whatever it is. But specifically about like flat Earth. What would it take to change your mind?
What would it take to change my mind? Any type of physical proof of a dome over us, which I don't see happening because there have been, meteors happen all the time, and I don't know where else they would come from if
All
there
right, so
was a dome.
we would have to discuss meteors because that would be a like
And it's not an assumption because it happens. I mean, that you can look them up on any news channel you want, no bias, whatever. You can see them fall through the sky. You can see them burn up in the atmosphere.
well, right. You can see something, but what I'm saying is we can't physically test what it is. So,
Well,
like, let's say
you
for
can.
instance,
People go collect these and sell them for lots of money. Like there's people that go hunt. There's like a couple YouTubers who aren't that, famous or anything that go collect these things and sell them because most of them are iron or some sort of metal.
no, I know, but what I'm saying is you don't know you can't really validate that's something that just didn't get shot up and came back down.
Oh, you know
Hey,
what? Here, I'll be to accept the Earth is flat. If they do this final experiment and the sun does not set in those midweeks in December, I will 100% accept it. Right here,
they
live.
yeah, I would say that's faulty thinking because the reason why is because well
How is that faulty
if they
thinking?
don't,
Because Dave said the same thing
you
way
said if
back. Now he's trying to cover himself by saying, "Well, it's not going to prove what the lights in the sky are." But he said, "Yeah, same thing with Austin." They said the same thing. Like if the sun sets in Antarctica, I will be, or if it doesn't set, there's a 24-hour sun in the middle of summer in December, I will be reevaluating things. Like I will actually step back and take a look. Oh wow, maybe I'm wrong.
well, right, but we could just be wrong about the light instead of the shape of the Earth.
Well, but then that ruins the whole model then, because how is the sun down around the edge?
Yeah, so Joe Hanvey shows that in his videos too. He
But
shows how the
no,
24-hour
he
sun.
shows two different lights, and he's using the coffee cup caustic, which again is an
Yeah.
assumption that there is I don't know, reflective but not reflective. And he's using the light that's outside of it. Is the sun inside? Is the moon
Yeah.
inside?
So he and that's what I'm saying. If you watch the progress, he goes through the progress of how he's developed it, right? So his earlier videos had a different thing not then than they do now, right? So if you're watching like an earlier video, it's going to be different than what he's showing now.
I think I can't tell if it was an earlier video or not. It was because
Yeah,
I saw, like I
what
said,
I'm
I saw
saying
you
is,
tagged him in it and had the red light in the middle. He had the little lines drawn out under the dome. So
yeah, I haven't watched all his videos neither, but
it is gorgeous tonight.
what
I
I'm
bet you
saying is
get gorgeous skies too.
it was a process, right? Like I started with this. This is what I started with, and now I have
Yes,
this, and it's different,
yes,
right?
that's exactly how, and that's exactly how like we got to the moon
And
because it's all a process.
he's learning as he goes, right? So so it's a
100.
process. So
Yeah, and that's science, and it is science. I'm not gonna
sure,
discredit the man. He's
absolutely,
trying to, he's working it out. It's not always a success. We don't
yeah.
know everything. There's
I
still
sent
so
him
many
the
unanswered
invite
questions.
to do this live stream with us because I was hoping he could answer some questions, but and I'll try to touch
Yeah, I
bases with
would.
him. Maybe sometime we can all three talk.
Look, I'm open. I'm open to talk about anything, and I like I said, I like to think I'm open-minded, but there are certain things that maybe I can't personally prove them because I don't consider myself like too intelligent, but I do trust the work, and I know.
Yeah, and that was a hard thing as well. Some of the things are different for different people, right? So like some people might have a hard time with the like let's say the 24-hour sun, or some people might have a hard time with explaining the constellations, and for a lot of people, it's a different hang up than other people. And so, like for me, I haven't trusted the government for a long time
I
because I was in the
100% get
army
that.
for 22 years, right? And so, you tell me one thing and we're doing a different thing, I'm already
100%.
not trusting them. So
You don't
I
care
have
who's in
very
charge
good
over
reasons not
there.
to trust. And so anyway, any institution that is government or federally funded or anything like that, I'm already questioning that. So like NASA, oh, but NASA has shown me this, NASA has showed that. That wasn't a big hang up for me personally because
Yeah,
I
because the government.
already didn't trust the government, right?
But also, they're NASA that so they are government, sure, but they hire scientists, and scientists are of a different breed. Scientists they want truth. This is why, like, when I watch these other, videos, truth seekers, people who really want to know the truth, but then they keep claiming that the Earth is flat. I feel like there's just some bias going on, and I do 100% believe some of them know that it's not. Sergeant for sure, dude. There's no way. There's no way he's still thinking what he's thinking. I mean, he's been on
Mark
like
Sargent.
national news, yeah, and
Yeah,
to see him just
I don't actually support a lot of specific flat earthers. Like I support Dave Joe Hamby because I've seen his work and I
yeah, we'll see.
Joe Hamby, the guy that did
Oh,
the
I thought
star
you
video.
said okay.
I
I
did
got
say
you.
Dave, but I don't support a lot of them. And again, some of the things are like you're spouting some things that aren't actual evidence. You're saying things that aren't measurable. You're kind of going off on this thing on your own.
What's not measurable?
Was that?
What's not measurable?
Well, just some things that some of the flat earthers say. It's like, how do you know that? You can't really say that because you
Yeah,
can't
it's like the
actually measure that.
firmament. You can't measure that, and like, 'cause so I see that video a lot with the rocket and the highest, like the uh, God, not a pro, but
It's the GoPro
whatever.
amateur rocket. Has the
Amateur,
dome
that's the word I
firmament.
was looking for. Not pro.
Yeah.
You're not a pro, you're an amateur. Yeah, the amateur rocket, and it's a lot of it's a de-spin maneuver because you've seen how fast that was going. Everybody saw how fast it was going. So anything that comes to a sudden, like straight up, if it hit something, it would be obliterated. It wouldn't just.
Well,
The only thing that happened in that video
and
was it
that's
stopped spinning.
yeah, that's and so for me that it didn't even do anything for me, right? Like the entirety of
It
the
just
video.
opened the door.
Yeah, and it was just because of that word. That's all it was. And
Yeah, that's okay.
and
I see it.
I only use that video when I'm talking about how I got into it as my testimony,
Absolutely. No, I
and
gotcha.
and just to point out like the location of the moon, because where it
The look.
was the location of the moon at the time shouldn't have been seen because it would have been on the other opposite side of the Earth, but they can see the moon in the video.
I'll have to look that up. Was it when the rocket was at its peak and it finally stopped spinning?
Yeah, so the
Like
rocket goes up,
130,000 feet?
it hits the firmament or whatever, right? It hits something, it hits a superfluid or whatever, and then stops, and then now it's kind of doing the rotation, whatever, falling
No,
back
well,
down, coming back.
that's what it did. It didn't see. That's the thing. It didn't stop when
No,
that
I'm just
happened.
saying.
It just stopped
Like,
spinning. But that's when you
yeah,
see it,
what
is
I'm
when it
saying
stops spinning.
when it's starting to make its descent and it's starting to move, like like it would like just come across. As the camera came
Okay.
across the sky, you can see the moon, and you shouldn't be able to because it should have been on the other side of the Earth.
The Earth. Yeah, I remember seeing another video like that too. Someone was talking about that. Because they found the date that it was launched and
Right.
the location it was
I
launched and
I
they
only
found the
use
moon.
I only use that video really to point out the two things. I can't say that it. I mean, it sounds like it hit something, but again, that's not a sound can
Yeah.
be manipulated.
It was a kaplunk from the anti.
Yeah, it could be
It's something
whatever,
that
right?
spins the opposite way. That's what most rockets do because they spin when they go up.
Right.
It's
It'd be
just,
like you're running your engine and then you throw a rod. Like in your car,
throw.
you get that
Yeah.
you get that kaplunk.
Yeah, right.
Yeah, or if you're driving and then you throw your car in reverse, you get the same kaplunk, you know. But
So
like I said, I only reference that for those two reasons,
the
for why
introduction
I
of
got
what
into
got
flat
you
Earth
into it.
and for
Yeah.
that moon thing. So like we're talking about the moon, let's talk about this. Let's talk about this observation in that video of the moon, right? Forget the
Yeah.
rocket, forget everything else. Why is the moon visible, right? And
I
so that
don't.
would be
I'd
a
have to look
point of
that one up,
conversation.
and I'm
Yeah.
gonna check that out when we do get off this. I will look that up and see where it was, the moon, and all that stuff.
Yeah. So and then like I said, I like to really get to something that's tangible, you know. So
Geology,
like was that
volcanoes, tectonic plates, asteroid impacts that we know of off the Yucatan, I think it is, from Mexico, like that killed all the dinosaurs.
no,
No. So
no,
and
that's not
so this brings,
that, that's
if
a
someone's
spot
in
that
front
you
of me
can go to.
speaking Mandarin, right? If they're speaking Mandarin and I'm saying what you're saying isn't real because I don't understand it, well, that's not true.
Oh yeah. And remember I said that people reject what they don't understand, and I
And
still
that's
hold to
what
that.
a lot of the science is, like to measure the speed of light one way, radar, Army uses this all the time. It can only go so far too. And to actually get those numbers, crunch those numbers, do the calculus and measure it, that's not something I can do at this moment.
No, yeah,
I
right,
fully believe
yeah.
anybody at any time is capable of learning anything. I do believe that if anyone puts their minds to something, they can do whatever they want to do. But at this moment, no, I can't crunch those numbers. But
Yeah.
it's
So
like,
again, but what I was saying about the thing that supposedly killed the dinosaurs, I mean that's a lot of narrative with a hole in the ground, but it could be explained with something else. That's what I was saying.
I guess. I mean, 'cause you can't deny the fossils.
Oh, what
Like
fossils?
dinosaur fossils, all sorts of fossils. Like,
What fossils though?
what do you mean what fossils?
Yeah, like what fossils? Like what fossils are you talking about? Like
Any
where? When?
any fossils, any dinosaur fossils, any prehistoric, I don't know the exact names
I've
of
you
the
know I've
Jurassic.
never encountered
Never
an
been to a
actual
museum?
fossil. No, that's what I'm saying. I've never encountered an actual fossil from a dinosaur. Now there's actual fossils from things like a wolf or things like that. They have actual fossils, but those things that are dinosaurs are not actual fossils.
As some, so you never, wait, why, wait, okay, proof?
In no museum do they have actual fossils. They're all uh,
Well, they're not bones. They're fossilization. So it's not actual bones and DNA.
no, it's not actual. It's made with plaster of Paris and stuff like that.
No, but they're not. So you're saying there's not one actual fossil. Okay, so you're denying dinosaurs now.
Well, I mean, dinosaurs is not important for me. And then dinosaurs never made an impact on my life at all.
It's the history of it. Okay, so same thing with, I guess, Pangea and the volcanoes, the tectonic plates, earthquakes. I did catch that one post you made about why they were using so much concrete for their satellite. That is a very um tectonically active area,
It is. It is.
and they're making essentially like a giant spring with their big foundation because it takes a lot of mirrors and a lot of really expensive stuff to make a really good telescope.
Well, yeah, but leaving aside just the leaving aside the telescope itself, you know, there's a reason why they need so much foundation work and not just the shock
It's
absorbers, because
heavy.
there's a lot of the telescopes that are built, they don't have those shock absorbers on there.
Yeah, this is also a very big one. I don't have to look more into it. Because I know there's plenty of telescopes in California. There's a lot of they're like up at high altitude and stuff to get above Hawaii too. That's another big one. But
Right.
you can
Yeah.
also, so all right, I'm gonna shift real quick to the things telescopes look at. So and I guess this won't help prove what we are on, but you can't deny that like Jupiter is a thing, right?
What do you mean, like a thing?
Like it's a planet.
No, I don't agree with that, because that's not that's I don't agree. Well, first of all, the etymology of planet means wandering star, so
Yeah, every
it's not a
word
physical.
comes from something else. Then, of course, when they were called the planets, they didn't have the telescopes or the technology to really look at them. I mean, they did eventually. I'm pretty sure Galileo with it, because you could see the moons with the naked eye, actually, or with a very small, very minor,
Well,
like almost binoculars. You can see the
yeah,
moons of
what we
Jupiter.
call moons, because we can't actually know it's a moon, or it's just a light in the sky.
Well, the definition of a moon is something that orbits something else. That's the definition. It's a satellite essentially, but we call them moons.
Right. Yeah.
But we can right now tangibly buy a telescope, and we'll have to do this if we want to keep doing. I'll invest the money in a couple $100 in a telescope and sit here and look at Jupiter. You can see the atmosphere on Jupiter. You can watch the moon's orbit throughout, like in the year. You can see all these things. Us, not NASA, not no one else.
Right.
We can.
Yeah. You could, and I don't argue that at all. Like you can look up into the sky and see lights in the sky, and you can see what they do.
Yes,
We
and
can observe
that's
that.
why I turned away from that. I'm not going to say that's going to determine what we're on, but you can't deny that those are what they are, because
Well,
we're seeing them.
I can't say that they're bodies of land or planet, like a physical thing, because all I can say is that it's a light in the sky. Now how that light reacts, how it operates, I can't say any of that, because I can't validate that.
Okay, I'm also,
Like
I guess I'm
I
trying to get
can
to the. I've seen people share
we can
pictures of like,
we
oh no, this is Venus, this is the star, but it's just really an out of focus picture with a camera that's
well,
not meant to see
I
that.
wouldn't say it's out of focus, but
No,
you know,
they're
getting into like stars and what we can see in the sky and stuff isn't really going to help, what's tangible here on the physical earth, that we're on. So
but
I
it
really don't
so.
even.
I don't know. I guess my argument to that would be that it does, is because that's like everything else. Why would that be different than where we are at?
Well, it's
Yeah,
because,
yes,
and
I
that's
guess
what I'm
it would be
saying is
different. There's obviously things that are different, with
aren't
different
the same.
atmospheres, different sizes, different, but
Um,
it's the laws of physics apply. The same, like gravity still applies to everything. That's why we're able to calculate the orbits. That's why we know when the moon's going to be. That's why we know when there's going to be an eclipse.
well,
That's
if that could be calculated, if that could be shown and calculated without any of that, right? So like they were predicting the eclipses for thousands of years before the heliocentric model even came into play, and it was still accurate, right? So that's
says who?
irrelevant. Well, that's what they're. I mean, that's what before.
The narrative, the story.
Oh, sure, but they didn't have the heliocentric model. They didn't have gravity, but they still calculated the eclipses, right? The Mayan calendar, right? The Mayan calendar, if you really get into that, they shoot, they could predict things for hundreds of years and stuff before even the
Certain
heliocentric
observations
model
they
came
did,
out.
yes. They did, because
Yeah,
they
what I'm
didn't
saying
have
is
YouTube and
what I'm
stuff, so
saying
they
is
spent all night looking at
the
Orion.
lunar cycle, the lunar cycle hasn't changed in thousands of years. What
Of
has
course
been
not.
observed, for thousands of years is the same. So they predicted it even before they thought the Earth was a globe,
Well, yeah, and I don't argue that either.
without any globe math or anything. So
No, because they're just
saying that is
observing.
not a.
So, okay, but one thing that I don't know if it's the Mayans, they did have a whole different star that was there that is no longer there,
Well,
and
that's
it
a
is now the
story.
Crab
You
Nebula.
can't prove that.
What you
That's
just
not.
said though?
No, I'm not saying that it's. I'm not saying that. Like, okay, so back in
So a star went
1200
supernova,
or
and it is recorded. It's recorded. It's wrote down. The star like lit up the sky brighter than the moon. Recorded. And that the location they pointed at is now a nebula. It's now a gas cloud because a star went supernova. And it
when was
corroborates,
that?
like I get it, it's a story, but we can now look at where they were pointing at in the sky today and say, oh shit, that's where a star blew up.
Oh, so I was it kind of comes back to your starting point, right?
Mhm.
But it comes back to the telescope conversation. It comes back to
I guess, yeah. And it's an observable, repeatable thing. The boats going over the edge are observable, repeatable.
so we had talked about the Georgia Guidestones earlier today. And you
Yes.
had said that if you track the Polaris now, and then in a couple of years, we can see that it has moved. Okay, so this is what it all comes down to. This is why I named this video what is tangible, and
The
all
Georgia
that. So
Guidestone.
you kind of want to
I
get it
don't
all
know.
back
What
together,
did it
right?
look like? What was the thickness of the hole? Where did you have to stand? Was there a certain spot?
All
Because
right, so
if
you
I
know I'm
put a
going with that. The hole for 40 years, Polaris was in the hole, and it never moved
and you had
outside
to
of that
look
hole.
where you had to have your eye up on it like a rifle scope, or did you have to stand back from it a little bit?
No, I've never been
Well,
there. So
because if I put a hole in this stop sign right here and there's a star through it, well, if I walk over here, I can make that star go through it. If I walk a little that way, the angle of which I'm looking at, I can put any star I want in it.
yeah, I know that um and you could look all that up. I mean, that's
Yeah, because I
like
want
if
to see
we
the
looked up
thickness and how close they had
yeah
to
the
be to
dimensions.
see.
If we looked up the dimensions, and I said, okay, it was 4 feet wide by 15 feet tall by 2 feet thick, nobody would argue with that. I wouldn't think, even though we can't measure it ourselves. But so the hole was at an angle, and it was I'm
Yeah,
just saying, I don't know exactly. Let's say that hole that they drilled through there was 4 feet long, not just a two-dimensional hole like through a stop sign, right? It was like a 4
yeah,
feet long
yeah.
hole.
It's 4 foot long hole, like a tube almost. Yeah, no, I got you, and
Yeah,
that's my
and
point, I guess.
yeah, in 40 years it never moved outside of that hole, right?
And
So
that's also not a long time, cosmically speaking, though. Cosmically speaking,
right,
40
right.
years is
But
nothing.
40 years is nothing, and only in the last let's say 100 years. Let's say 100 years, they're saying that Polaris, they could observe Polaris moving, right? But what I'm saying is, this is what I'm getting to. This is what I want to ask this question,
Mhm.
because it doesn't line up with the heliocentric model. Our observations, regardless if, let's say it's not, let's say the Earth is a globe or flat or whatever, it doesn't matter, and we're only going off the stars and what we can see in the heavens, and we don't ever test the ground. The Georgia Guidestones and different things that have been observed and recorded for thousands of years have not changed. Okay, for instance, um, the Orion's, and I was getting to this, Orion's belt, right,
Mhm.
is lined up with the pyramids of Giza.
Well, no, that I will refute right now. Maybe from a certain distance, I guess. I mean, because I'm looking at Orion right now, and
No,
I
yeah,
get it. He's just a little closer to the
but it lines
equator.
up, just like Polaris lines up in the drill hole through that stones in Georgia Guidestone, right? Just like it lines up there for 40 years and hasn't moved. Orion's
The belt, the
belt,
three stars.
right? It comes around in the sky and realigns with the pyramids, right? I'm just trying to make a point here, and that's been happening, observed for thousands of years. Whatever, it
Yeah,
doesn't
because
really
the
matter.
pyramids are about what, 6,000 years old,
Well, whatever. I mean,
4,000 years old, something like that.
even
4,500.
that could be not accurate. But what I'm saying is, it's been observed for thousands of years. All the stars that we see, right? All the constellations, they're all in the same relative location to each other, position to each other.
Yes,
We see the
the
star
sun does
trails.
rise in the different constellations now than it did way back when, though, when they came up.
Oh yeah. The ages, because like the age of Aquarius, the age of Sagittarius, and stuff like that. That's a kind of a little bit different topic, but a little bit the same. But what I'm saying is, what is the fixed frame of reference for an observation that happens year after year after year after year? In the heliocentric model, what is the fixed frame of reference? This also goes to the telescope thing. Why does it need to have so much concrete in that telescope? Because it needs to be fixed, and they'll tell you this in the construction.
Well, but
if
that's
there's
not.
any,
At least the parts I seen of it, the concrete wasn't necessarily so it could be fixed, because it was concrete sandwiched between springs between more
no,
concrete.
and that's because of the
So
seismic activity. So they want it to be stabilized, so that they want
stabilized, yes, because they do need to be stabilized, because it can't move in order to get a good picture, to stack the
Right,
photos,
yeah.
to look really deep up there. It needs to sit still.
Yeah, so you have the
Absolutely.
concrete, the base, then you have the springs, and then more concrete, right? And between that, they're trying to keep the top stabilized, not the bottom concrete. They want the bottom concrete to move, but the top to be stabilized. It's the same thing in construction with the buildings, with like in Japan and stuff, right? They have the
because
earthquake buildings that'll shift, and let the foundation shift underneath. That's the same engineering as that telescope.
That's photography,
but there's
though,
many
is
other
why they
telescopes
want
that
it
don't
to
have
be
that.
stabilized.
Right, so
And
it
this
needs
is
to be fixed. It needs to be.
They're building that for a specific. I'm not really sure why they're building it, but that's like, I don't know, different reasons. Like we have Hubble.
Right.
we
Yeah, but
sent
what I'm
up-
getting at is the Georgia Guidestones, the pyramids of Giza, these telescopes that are all over built all over the world. They're all built from a fixed point of reference, right? And you can't have a fixed point of reference in the globe model because of
What do you
the
mean a
different
fixed point of reference?
Well, how can we see the same thing every day over thousands of years or 40 years? How can you see the same thing? You can't.
Because what do you mean you can't? Why are you saying you can't? That's you can't just say.
How many
It's been
motions
explained.
of how many motions?
The heliocentric model explains it. Things are very, 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 very far apart, like significantly far apart. If you watch a video about the scale of just the solar system, it's absolutely absurd.
I know it, but that's a story. That's
That's
not tangible.
It is tangible, just like someone speaking another language I don't understand. There is math that supports it, and I might not quite understand it, but the math is there, and as a result of that math, we are able to. I get it. I'm going back into the space shit, but well, all right, Artemis. Artemis is coming up fairly soon. It's like a couple years. We're gonna be going back to the moon. What then? Or is there nothing that they can do that will make you believe? Like nothing that they do, bring back, you see, I don't know.
Yeah, so
Artemis missions are going back to the moon. So like what would you you're not gonna accept any of that.
50 years, 60 years, 70 years,
Well, no, they really haven't. They stopped after Russia stopped. We stopped. We didn't really care to get to the moon. We'd rather spend money killing each other.
Well, I just say that's the narrative because that's what they want us to believe.
We talked about earlier governments killing people.
No, I'm talking about the reason why they didn't go back to the moon. The government's killing people that's not news at all.
What would be the point? The moon doesn't exactly have vast resources, and Elon's whole inspiration for going out and trying to get to Mars, his is a survival one. He thinks humans are going to go extinct, which that's very possible. But it's good to have a plan B. Okay, if everyone dies on Earth, at least we have a colony set up somewhere far away. but back then that really wasn't it. It was just curiosity. It was just and it was a race to beat Russia, who was our main competitor after World War II. It was just a flex. And then after that,
Yeah, I wouldn't agree with that because I don't think that nations aren't. I don't think they're technically at war with each other. They're all working together, and that's provable with that's demonstratable with the Antarctic Treaty and with space. Both
the Antarctic
areas
Treaty,
the common person can't go or can't explore themselves.
the common person
they
can
all
go
agree
to Antarctica.
No. That's you can't use
the Antarctic Treaty is about keeping the military out.
No, you can't use the narrative of people going there on a vacation.
It's not a vacation. There's a race around the world that happens all the time too. The Antarctic Treaty says the military can't go there.
They measure the distance further down below the equator than they do north of the equator.
What do you mean?
It's a further distance. Like they're measuring further. The distances below the equator are measured greater than they are above the equator.
The distances between what? I'm confused.
Just whatever. Like even the boat races, the distances are measured. They're not measured to what they would be identical in the north. They're measured longer.
They're measured longer.
Like, okay, so like for instance, you go from the south tip of South America to the south tip of South Africa, and on the globe model, let's say it's 2,500 miles, but they're actually measuring it at like, I'm not using the actual numbers, like 3,200 miles, right?
There are flights from Sydney not Sydney, it's Perth. There are flights from Santiago to where is it at in Australia? I was just looking at it the other day at the airport too. There are these flights that, and they go, they're not possible
Perth to Sydney, yeah.
No, not Perth to Sydney. It's from hold on. This is gonna frustrate me. I mean, I work at the airport. I've seen like there's other flights that happen. Yeah, I'm pretty sure it's somewhere in Australia. South America. Yeah, Santiago to Sydney.
Okay, cool.
So it's the eastern side of Australia to South America. There's a nonstop flight that does that. I don't think it's very frequent, but there is one.
Yeah, I mean, and flights are a whole nother conversation, and
we can get deep into that. Like I said, I'm happy to get, but and that's where my problem, I guess, comes in, because then even if I did get a pilot on here to talk, to say some things he knows, maybe some flights he's flown, he would then be paid. He would then be a shill. And that's not fair. Just like it's not fair to ignore the
well, like I told you, I
science.
have a commercial pilot friend that will not say anything on the topic. And it's because the job would be jeopardized. And so, it's just different, and again, I could take the word of a pilot that I talked to, and you could take the word of the pilot that you talked to, and we would still be in the same position that we're in now. We disagree on what the flight is or whatever, and so, that's why I stick to, like, that a flight can be manipulated, speeds can be manipulated. You can't actually tell when you're in the air how fast you're going. You can only take the word of what they say, right? You can't measure that yourself. You can't measure the.
Yeah, we're not allowed in the cockpits, or the cockpits aren't even allowed open anymore since 9/11, of course. But they have you
can measure time. How long does it take to get there? But you can't measure the airspeed because you have no way to measure that.
Well, they do. They are being measured because
I know. And
they
all
have
I'm saying
all
is,
these things on the plane. I whacked my head on one the other day.
I know we accept the airspeed, right? And we accept the distance because of the airspeed, but we can only measure the time ourselves. That's all we can measure is the time.
Or
I get on the plane.
So inclined I could go get my pilot's license and do it myself.
What's that?
I could go, if I was so inclined, I could go to, aviation school, become a pilot, and do it myself. Like, there's nothing
Yeah,
stopping anybody from doing
absolutely.
these. And it's just the people that have been to the moon, the people in the ISS, they're real people. Like, there's real live video footage from the ISS with, in microgravity environment, just sitting there all day. But I don't know what would
Yeah.
you, what's your answer to that, to the microgravity situation? This proves the globe
Oh,
being in orbit, seeing the ISS. I wonder where it's at right now. I'd have to look it up. But seeing the ISS pass overhead at the speed it does, with knowing that we can transmit signal to people in there, and we're getting the signal, and we're talking to them just like I'm talking to you. I believe you're in Alaska. You believe I'm in Boston.
right. But that's why I pointed out before. Like, I can't measure the distance to the ISS.
It can be
So
measured, though. It can be
it could
measured.
just be
It's just
it could just be it could just be 10 miles up,
no.
and it could just be a plane because it's
And
the same
again, we
size.
can see it. We can take a camera or a telescope and see the panels, which are not aerodynamic at all. They are outside of the atmosphere. Otherwise, that thing would break apart. And you can measure the speed by how fast it goes, how fast it moves across in the
Right, but
sky.
you have to have a tangible thing to measure the speed, which would be the distance, and we can't measure the distance. We can only be told the distance.
No, I'll have to look it up. But like I said, I'm almost positive there's a way to measure the distance, especially if they have something up there that they're transmitting down to us. And which they are, because they talk to us. There's a live feed all the time. We can see the hurricanes from up there. How does that work? Coriolis effect. How do you, typhoons, hurricanes, all that on a flat Earth?
Well, I mean, you're talking the Coriolis due to the spin of the Earth, which is not, again, which we talked about that, and
Well,
there's
that's
no
been measured,
evidence
and
that
that's been
the
measured
spin
by
can be
flat
detected.
earthers. The ringleader that they bought
I know
was
Bob Nodal. They measured a shift in the ether. What they measured was
no. He tried covering it, and you can't see. He can't do that. The whole video is plain as day. He said, if we pick up a 15 degree per hour drift, well, then I guess that means we're a globe. Never mentioned that it's a possibility we could pick up the spin of the firmament. Never mentioned that beforehand. But when he didn't get the result he wanted, he said, oh, we put it in this box, we put it in that box, we tried covering it in bismuth and all this stuff, but we were still picking up. He had no proof. He's just saying that. There was no tangible evidence to say that he was picking up the spin of the firmament or the ether. What could he jumped to that conclusion?
Yeah. And again, that for me, that's hold on a second.
He did his experiment, he laid it out, and then he jumped to that conclusion because he got the answer he didn't want. And that to me is not speaking the truth. Oh.
Go get mommy. Go get mommy.
How old? How old?
But so measuring the 15 degrees is also the measurement for the sun. 15 degrees per hour.
No, well, it's not just the sun, because that's also the rate that Orion goes around. That's also the rate when you're in the equator, you watch the stars go overhead.
Well, I'm just saying that the sun, they say, moves at a 15 degree per hour. Right? And so if it's also Orion that is moving at 15 degrees per hour, I've never heard Orion being moving at 15 degrees per hour. And I'm not saying that's not the case. I'm just saying I haven't heard of that. But measuring what they did, a 15 degree shift may not be the 15 degree shift in the planet. It's the 15 degree shift in the sky that's moving, just like the sun, right? Or Orion or whatever. It's the 15 degree shift that is measured in the sky. I'm just saying that's the other possibility, right? Are you there? All right. Hopefully Mike will be back soon. We've been having a good conversation again. There's lots to discuss. And hey, Isaac, I'll be right back. Can somebody change Isaac or? Okay. All right, things like the 15-degree shift and different things like that. It's not just one explanation, though. It could be another explanation, right? So if it can be shown on a flat Earth model, the 15-degree shift, then and it's not the actual Earth, but it's something in the sky detecting that shift. Then there's a second explanation for it as opposed to just one explanation. And so, that is that a tangible thing? Is that something that we can prove ourselves? Certainly we can see a 15-degree transverse of the sun, and you can say what measurement that is and all that. You back there?
Can you hear me?
I didn't add you to stage. Sorry.
Can you hear me?
No, I can. Yeah.
Okay. Hold on, I need a battery. I didn't get a warning. Like, it didn't even tell me nothing. My phone just died.
Oh, really?
Yeah. I have a portable battery, though, so hold on. Probably grab a hoodie.
So I was thinking about this the 15-degree shift in if they detected a 15-degree shift. Think about just an alternate explanation would be that the stars and the stuff in the sky is moving and not the Earth. Like, for instance, you could take your ceiling fan, right, and you know that your ceiling fan is moving. And if you put like star constellations on your ceiling fan, you could create the same effect of star trails that you would if you're just observing the stars moving.
On the ceiling fan, yes.
So you
Not
can get
all of
star
them, though.
trails
You
on a
couldn't
ceiling
do
fan.
you couldn't do all the star trails because, like I said, when you move to a certain point farther south or north, they will continue to go. They will.
No, yeah. So then we get
the
back
way
into
to replicate it would be to put yourself on a ball or something and put all the stars around the room instead of the fan and spin that way. You put every single constellation, but because if you do it on the fan, you're not. It does. How does it all of a sudden start spinning the opposite way?
All right. So though I can't remember who did it. Actually, somebody did that demonstration with the ceiling fan and how it turns a different way and stuff. And I can't remember it. I couldn't even
unless
find
you're
the video,
on another side of the blade. That would be the only way. If you're on a different side of the blade, which was just like being on the other side of a globe, that would be the only way.
Well, what I was pointing out was just the 15-degree shift. You could demonstrate that just by using like a ceiling fan, and you could slow it way down to a 15-degree shift,
Yeah, okay, but see, if I'm not on the fan, if I'm not on the fan and I'm in the room, okay, and the room is, all right, here you go. I'm on a train, right, and it's moving, and then I have a fan on the train that's just spinning above me, and I want to know how fast the train is going. I wouldn't sit here and I had a device to measure, a gyro or whatever the hell measures how fast the train is going. I wouldn't say the fan is all of a sudden give me that speed. It has nothing to do. I don't know why. Where does the sky connect? That's my question. Where does the sky connect when they're using a gyro to detect our movement of where you are at, and all of a sudden it's picking up the motion of the sky. How does that connect? Because that's
How did it?
genius. That's I mean, how is it picking up the spin of the sky if it's not picking up this? Because the gyro stays in place. The gyro is when it's spinning, it stays in place as opposed to us. That's the whole point of it. That's like a pendulum. I'm pretty sure you can do the same thing if you get like a pretty big
Yeah,
pendulum and you let it
the
swing, it'll show
Foucault's
you the rotation of the
Foucault's
Earth.
pendulums has been debunked too. So
But
like to observe the spin of the Earth.
yeah,
Eh,
I haven't looked too deep into that.
yeah.
I know that's one way
So
to determine it.
all the Foucault's pendulums that you can go to and see, they're all use they all use electromagnetic force to make the pendulum shift.
How do you prove that?
Well, it's in the construction of it,
It's in
right?
the
Like in the actual construction design of a Foucault's pendulum, it uses electromagnetics to make the shift. It's not just a pendulum that's sitting there. It's
so okay. So what
manipulated by
device? What's
yeah,
it being
it's
manipulated by
manipulated.
then? If not gravity, and it, or what? Like how is it being manipulated? What electromagnetic?
Well, like you turn on, you have your magnets surrounding the outside, and then you turn them on. They're turned on in a series, right? And one turns
Yeah,
on,
that well,
the
that'll
next one turns on.
move. Yes, okay, I understand that. I didn't know if that's. I
Yeah,
thought.
so there's no Foucault's pendulum that has a system running without electromagnetics. So it's like if you go to like there's one in Australia and different places.
Yeah, because it's
And
supposed to keep it moving. It's supposed to keep it swinging. Something
right.
obviously has to give it a.
Yeah. So
But I
you
do
swing
know
the
the ring
pendulum.
laser gyro has been proven not just by flat earthers who proved that. Bob, God rest his
Bob
soul,
Dole, right.
Um, but that's been a proven thing, and that I don't know. I
No,
guess back to my original question
that's
is
the
how is
only
that picking up the spin of the sky?
it's done with the laser. The laser's detecting the movement.
The ring laser gyro, yes,
or the variance.
it's because that's how the gyro works. It spins while the thing around it is that like planes use them all the time to keep them level, and because things around it can move, but it'll stay stabilized. So here on the Earth, the thing is moving, but it's staying stabilized at the setting it was at. So what does that have to do with the sky if it's down here? That was my only problem with Bob's whole thing. I don't understand how before the experiment he didn't mention
No,
the
I
possibility.
know it. I know, like there's others too that have said one thing and then they do an experiment and it didn't turn out the way they wanted.
And then
So
the
they
laser
say
one, after that whole thing failed, they did the laser thing and he raised it up. And like I said, I know that's piss poor editing to really make it look bad. I don't truly believe that whole film Finding or Beyond the Curve or whatever it was called was necessarily meant to really make anyone look bad or anything.
yeah, I'm gonna drop my. Oh, I can't do that. Okay, that's fine.
So, and you don't see a correlation with the sun moving 15 degrees as well as the constellations.
What do you mean correlation?
Like either the constellations are also spinning around 15 degrees per hour. The sun is moving across the sky 15 degrees per hour. But they're separate things, right? They're not. We can agree that the sun is completely different than the stars in the background to an extent. Why would they both be moving at the same speed if it's not us, if it's not we're the ones that are rotating?
That goes back to we were talking about like the age of Aquarius and all that. The sun moves with the constellations, but they move at a slightly different rate, right? But in our age of Aquarius, whatever we're in right now, we're moving at the same rate as the that constellation.
Well, I thought the
time
way
we're in.
that was,
Right.
yeah, it's just because that's where the sun rises in that constellation for that month or whatever. I thought that's how.
So
I don't
like,
know too much about
let's say
astrology, star signs.
let's say it's 1,000 years or whatever, right, between each constellation movement. Let's so if the sun move, let's say the sun moves at a constant 15 degrees,
It,
per hour, but constellations move at, let's say, a 15.5 degrees per hour, right? So for 1,000 years, it's going to look like they're the same, but then as that time gets closer, or further apart,
oh, it
then it changes.
shifts.
It shifts right into a different. The sun shifts into a
Constel-
different
Constellation that it's
constellation or era, right?
yes, and that's due
Yeah.
to
So
the precession though of the poles of the moving of the Earth. Like that's easily that's
so
I don't know.
so
That's explained by our model, I guess.
right. So what we got to do, right? In this topic or whatever, right? Is how can it be explained in this model, right? Or how can it be explained?
The
Not.
flat Earth model.
I think we should get away from. Yeah, I think we should get away from it can't be explained, right? It doesn't work on a flat Earth model. It doesn't. I think we should get away from all that because that's just a lack of understanding. So like I can give the answer or an answer why the sun. So the constellation is moving, at 15 degrees per hour, but the sun's also moving at 15 degrees per hour, right?
Mhm.
But it's only moving at 15.1 degrees per hour. So eventually the sun is going to move out of that constellation into the, whatever, right? The other zodiac, right? So
But it's
then
not moving. They're all
for,
moving at the same rate.
well, I'm just saying, I'm just trying to say, like, eventually the sun is going to be in a different constellation. So right now,
yes.
the Orion and the sun move in the same, like, at the same speed or the same time, right?
Yeah.
In a sense. And I guess the way I would kind of demonstrate that is, you could have two, with gears on your bike, right?
Mhm.
You have like the bigger outer gear and the inner gear. They're all rotational. They're all moving at the same speed, but the inner gear makes your tire go faster. So they're all moving at the same rotational speed. But as the sun changes, it's going to change the overall, right? So I guess that would be a way to demonstrate, But
See,
again,
that's
that
a
would,
good point you bring up though about the
yes.
rotational speed, because that often gets confused about the speed of the Earth and how are we moving 1,000 miles an hour. We don't feel it, but that's our rotational speed is 15 degrees per hour. It's one spin per day.
Well, yeah, but it works out to be 1,000 miles an hour.
For your distance traveled, yes. If you're at the equator and you are, at this point, and you were to just, okay, I'm gonna measure where I would have been, or I'm going to be an hour from now. Yes, you would have moved 1,000 hours in an hour, 15 degrees an hour. The farther you go up, the slower it'll be. This smaller circle you'll be doing, just like with the gear, because we are on a sphere. And the constellations, see, I don't know. The constellations to me are concrete evidence of it. There's no other. If you look at any time lapse video, at least when I look at any time lapse video, you could see the movement of the Earth. The stars are coming from beneath the horizon and they're going around. It doesn't make sense if the Earth was flat. They wouldn't do that. They would all spin overhead, like in a circle.
Right. So the visual perspective of the stars, constellations, whatever, coming up from below the horizon, explained on a ball Earth, right? That's what everybody does. That's what everybody knows. Now, how do you explain that on flat Earth, right? That's that's like the questions that should be asked. How do you explain it on a flat Earth? You don't say like,
But why are we asking
it
that
comes
if it
up from the
works?
horizon, so that only works on a flat Earth or a ball Earth.
Because that's a
But-
part of repeatable, observing, repeating. That's a part of it. And
Well, yeah, because
I can't.
and that brings me back to the fixed frame of reference, because it is repeated every year for thousands. We have to have a fixed frame of reference, and that fixed frame of reference tells us the Earth is fixed and stationary.
Well, we can see the orbits of the planets, the Venus, Mercury. They orbit one way, and then you got the retrograde. Like, if it was just
Well, yeah,
us, I guess, and we couldn't see anything else, I would
but
understand that. But we
that can be
do know
explained
that.
in a flat Earth model as well. Not that I can explain everything, but I'm saying it can be explained in a flat Earth model.
And that's my point. And see, that's my point with the globe too. Is not that I am capable of writing out the math and the equations of it all, but it is explained and it works.
Yeah. So what I've been encountering, I guess, is this works in the globe model. Yes, when you have your model and it matches what you observe, you works in that model. But to say it doesn't work at all in a flat Earth, Earth model,
I'll never be convinced that the moon works in a flat Earth model. I'll never be convinced. If there was a possible way, see, there's just not though, because we know too much about the moon, and even if I didn't know anything about it, if I were a traveler, Magellan, whoever, and I was watching the face of the moon, slightly go in one direction, the farther south I went, and I'm not seeing another side of it. It's moving towards the sky. I'm not seeing any different angles. I'm not seeing the back. I'm not seeing the front. That obviously would be a question in and itself. But there's no other shape. And as I'm moving and I'm seeing the moon, the constellations are also changing. And I'm not seeing previous constellations. And that doesn't work on a flat world.
Well, your concept of it doesn't work on a flat Earth. And that's what I was getting at, right? When like globers say it doesn't work on a flat Earth, the globe concept doesn't work on a flat Earth. Yeah. So there has to be a distinction. When you use globe information, the globe information
it's not globe
doesn't
information,
work on a flat Earth.
That's it's reality though. It's not like globe information.
I was trying to use a different word than narrative.
I know, but
what I'm saying
goes back to religion though. If you throw out all those books, math will be the thing that comes back. Pi will always be 3.14, the ratio of a circle to its circumference, or the diameter of the circle to its circumference. But like these things are constant. These things are proven. And yes, of course, the sky doesn't change over time because it's very big.
We can say these are proven, but I want the assumption of the globe to be proven, because all I ever get right from anybody is speculation, assumptions. This has been proven, but nobody actually.
The only way you would get to like Thomas needed to see the holes for himself. I would honestly probably be like Thomas. I need to see the holes in order to believe he came back to life. And you would have to literally study these things and go to NASA, and you would have to go into orbit yourself. Like, because other than these,
so that brings
having a little bit of trust.
My question, right? Yeah, that brings me to my question. Like, what would it take to change? Let's say the answer is, and I get this answer. So, and that's why I started asking the people this question. What would it take to change your mind? Is because
to see a physical firmament.
I would have to go. Yeah, I would have to go up in a rocket, and I would have to see. But you didn't do that to get your viewpoint. So you're using a false idea to.
Well, no, we have
something
used
that
it.
You didn't get to begin with.
There isn't even a thing we can claim as CGI for flat Earth. There's not even a video that we can say, no, that's fake. It's not the Earth flat. It's not the firmament. There's not even that. Yes, the horizon's going to look flat. So okay, we have all these videos that are being claimed to be fake, they're being claimed to be CGI, whatever. We don't have that flat Earth. There's nobody that has that. Oh look, there's a picture of the firmament. Oh look, there's the lands beyond Antarctica. Like there's not even anything.
Yeah.
There's
Yeah. Yeah. So,
the ether was
so
as
again,
proven.
I can only validate what I can validate myself. I can only verify what I can actually do. I can't validate anything that's in outer space because I can't physically do it myself.
But you can validate gravity, right?
Yeah.
I mean,
Theory of gravity, the theory of relativity is
I let something
what
go,
though?
it falls. Why does it fall?
Yeah,
I'm asking why.
so that's the question, but then you answer something that has just been told to us, right? So
Well, no, so then I'm saying give me
electromagnetics.
another proposition, because when flat Earth first
Yeah,
came
yeah,
out
right,
a while
right.
ago,
So
they used to say we were being pushed up constantly. I'll never forget that years ago. This was like 2015, maybe 2016. I remember seeing flat Earth stuff, and someone said that we were being pushed up constantly, and that's why things fell down. It has since been revised, but I'm sure you can still
that
find
was
videos of it.
that was misinformation by the Flat Earth Society. That was not by flat earthers, right? So that was on the Flat Earth Society website. That was not taught by flat earthers actually teaching about flat Earth.
But that
right?
was okay, because it was a joke. They started it as a joke, and then I guess it turned people into, oh shit, maybe it is flat.
And even but so I don't like to really use other people's words, like I don't want to say like, hey, because Dave Weiss said this, I don't want to use as Bob Nodal did this or whatever. I don't even particularly want to use what Joe Hamby does, because and I don't speak for him, he doesn't speak for me, right?
Absolutely.
And
You want to
so,
prove it ourselves. You want us to be completely disconnected and
but I
say,
only use
okay,
him
it's a
because
globe or
he
it's not.
demonstrates the answer to the question. That's why I use Joe's stuff or recommend his stuff, because he gives the answer to the question. But again, what I can do, and what I promote or whatever. What can you do yourself? What can you validate yourself? Like I said, I can go to Lookout Mountain, and I can validate this for myself. I've been there. So and I have pictures to prove that I've been there.
Yeah.
Now,
You have been there and you've seen far, but
from
that math needs some checking. That math of the curve and all that, it definitely needs some checking.
No, yeah, I'm not saying don't just believe me. I'm saying validate it, right? Validate it. And so I can say that I can see, I think the greatest distance on this thing is 120 miles, I think.
And you can prove that how?
What's that?
How do you know it's 120 miles?
No. On the picture, right? On the stone here.
So what point out there is 100?
Yeah, in this direction is 100 miles. Now I know that I can.
But is that not somebody else's narrative? That stone
no,
saying
that's what I'm saying.
Hey, trust me, this is 120 miles.
No. That's why I don't just believe these arrows, right? I go here and I actually see this whatever it is, 120 miles away, and you got, like I said, a building out there that's 120 miles away, whatever, right? That I can validate that.
And you validated, but how did you validate? Okay, you drove.
I can drive from here to there, and it's not a straight line. Is going to be like 150 miles or whatever. So, or the driving is going to be 150 miles because it can't go straight line distance. So straight line distance you can measure, and what would you use to measure straight line distance? I can't physically measure, from this point to 120 miles. I can do it by driving, I can do it by, using a map or whatever. But I can physically see that. I can physically see that building with a zoom lens or whatever, right? So I can validate that for myself. And so leaving off, like for me, leaving off all the other stuff that I can't even, I'm not going to buy a $6,000 telescope, right? I'm not doing.
You don't need a $6,000.
I'm just saying, I'm not going to spend the money that I can't that I don't need to, right? This costs, $27 a person to get in or something. I can bring my camera there.
You're trusting the math. You're trusting the math that there. And you're saying, I believe that this is the math for the curvature, but I'm not seeing it. So, but if you believe that, then why are you not believing all the rest?
Math of the
no, because you're refuting it because that's what you're saying. I'm seeing too far. I shouldn't see this far. Right. And I am no expert. I am not that good at. I'd really have to look at how far we're supposed to see. I'd rather leave that up to a mathematician, just like I'd leave a plumber up to doing my stuff.
Yeah. So, what all I'm saying is that there is on a globe, there has to be a rate of curvature.
Yes, and there is.
There has to be, right?
Because there is. This was known for years. There is, and I've seen it myself.
So
never over land, unfortunately, but I have always seen it over the ocean.
The point of the Seven States Monument and is 120 miles away. Between that point and this point, okay, if you took out, even if you took out just all the terrain and you were just at an elevation of 1,700 feet above a smooth ball surface at 50 miles, at your elevation at 50 miles, that's where the physical curvature of the Earth would be. You can't see anything past it, and it wouldn't be just like, oh, I can't see past it because, like we talked about, things can be above that, right? But your angle of view, right, is a straight line angle of view. And in the military, we have what's called dead space, right? So like here on this 7 states, dead space is what I can't see like below this rock, right, without looking over the top of it. So my range of fire, right, would be limited to like this tree line, right, which might be 20 miles away, right? I'm not saying it is. I'm just saying I can't see what's below here. I can't see anything below there. Right. So just like that, anything below here would be anything below the curvature of the Earth. I can't physically see any of that. That's dead space, right? Anything above that,
what happens is in reality, the Earth curves.
Yeah. So and that's what I'm saying, between 120 miles away, right? You have it's like I can't remember what it was, but at 120 miles away or whatever, 75 miles away, there should be a distinct physical curvature between you and that observation point, right? There should be, even if you're elevated looking down, right? That curvature is still going to happen eventually, right? And that curvature, the rate of curvature with the calculator that I used was 50 miles for 1,700 feet. Right. And I could do that with different calculators. I could do that with, multiple calculators. And you could do that. AutoCAD, you could do that. And then I physically go out and view something that is further than the horizon would allow. Then I have to question, what is the
curvature? No, I know. That's what's its whole thing too. I'm seeing this too far, and I get it. But my only answer to that, I'm not a mathematician, and I'm not almost positive. I'm 100% willing to bet my life that there is something going wrong with the numbers here. Because, and if this is the case, right? Why on any of these things I see too far is the sun behind it? Why would a mountain be blocking the sun? If it's flat, it doesn't matter how far away the sun is, it'll never get to my eye level.
Yeah, so it goes into different aspects of even perspective. Perspective is real whether you live on a ball or a globe, right? All right, let's 100%. See. I'm gonna pull up. I'll remove this.
It doesn't matter how
And let's-
far. So the agreed upon flat
Let me-
Earth sun
let me
is
show you
like
this
what,
real quick.
4,000 miles high.
Well, you can't measure it, but let me show you this real quick, right?
Uh,
So what we have, right, is, do you see the little guy in the mountain?
Yep.
Okay, and then the straight line is his field of view, right?
Yep.
And then that shaded area would be everything that you
shouldn't be
cannot
seeing.
see. Right. Anything above that you can see. That's not what like 50 miles, that little 50 miles above the site. That's not what I'm talking
And
about.
no, and so I'm hearing. I'm hearing you with this. I'm just saying that whether it's a calculator or something, the math isn't mathing, and you can't do it everywhere because if
Well, this example is I'm on
from Everest we
I'm,
should be able to see, Paris, if that's the case.
from Everest, you're only going to see so far anyway. The physical curvature is going to be blocking anything in the way. That's what this would show, right? Anything in the shaded area below that physical curvature. Talking about anything that you can see above the physical curvature, or the 50-mile marker is anything above this shaded area. Not what I'm talking about. I'm talking about seeing things that are in the shaded area that you shouldn't be able to see because the physical curvature of the Earth is blocking your line of sight to those things. In the military, we call that dead space. We can't shoot those things.
No, and
that would never happen, right?
120 miles from a certain elevation, and the Earth being 25,000 miles in circumference.
It seems like it seems like it would be insignificant, but it is significant. And you could say it's so big that you can't detect it. Then you're just throwing out the curvature altogether.
No, you can't see. So you can't see, obviously, if you go out to the ocean and you just look, it looks straight. 100%. I agree with that. Even in a plane, it looks very straight. You're seeing farther, and you're also not just seeing over a circle. We're seeing over a sphere. So it's
right.
It's going down in either direction. So it
should be.
It's not like I'm just looking over. It's not like I'm looking over a tire. Like it's a whole sphere.
Oh, right. Yeah. Right.
Which changes. I'm pretty sure it changes the formula a little bit.
Yeah,
too.
I know. So let's say you're on. It makes it worse. If you're like, let's say you're on like the, you're on the Arctic Circle, right? And you're looking along that latitude on the Arctic Circle. That makes the argument worse because that is the curvature, the rate of curvature. So yeah, if you're looking, going sideways, or if you're on the side of a ball, or on the upper, I had a ball here.
Well, ball is still a ball.
No, I know, but you could be looking at different latitudes. All right, let me try to do this. Okay, so like on your globe, right? You have the equator, but up here in no boy, if you're up here in like Greenland area, your circle is smaller than the equator. And if I'm looking directly,
I see. I see what you're saying. Yeah, like
directly,
if you were to slice it at an angle, but that doesn't matter where you're at. It doesn't matter where you do that on a sphere.
No, that's not accurate though. And I thought about that for a long time.
You can hit the sphere from any angle, and you can slice it. That Greenland spot you just were talking about, it could easily be Africa, and that's just the nature of a sphere.
No, I know, but this is I have a page, my Facebook, called Project Annulus, and I haven't gone into it yet. It's kind of work at project. It's a place where I go to
Yeah.
have conversations with people without interruptions. But the idea of annulus is smaller circle for smaller or greater rates of. Man, where's the? Okay, so that line that I drew there, right? You would agree that this line up here is circle. If you were to cut the globe off at that line of latitude, right? If you globe off at that line of latitude, and we had just a flat surface of where we cut it, that outside circle would be smaller than the equator, yeah?
If you went further in, yeah, 100%.
Yeah, so if I just cut this, let me go back to here. I can see it. If I cut this off and it's just, so I'm looking in this direction, right? I'm going in that direction. So this circle that would be cut off is going to be smaller than the equator, right?
Yeah, so unless you cut it off at the equator, unless you just.
Yeah, I'm just talking about that latitude. This circle up here, and that's the whole thing with the.
The
rate of rotation, right?
Yeah, the latitudes are smaller.
Yeah,
yes.
So then your curvature, your rate of curvature increases because the circle is smaller. Okay.
So the latitude is okay. Because that's how we had it marked out, the longitude. It completely circles, whereas the latitude goes around and it goes up. So it gets smaller. The latitude circles get smaller.
Right.
But as a whole, it doesn't matter where you mark the latitude at. You're still standing on a sphere. You get.
I know, but the rate of curvature changes drastically if you're going latitude and if you're across the sphere. So let's say this is the cutout of this.
Yeah, okay.
So this is the cutout,
yes.
right? That was the latitude where we cut it straight off. This outside represents the that circle is bigger than this circle. The equator is bigger than 32 degrees north, whatever, right?
But if you're standing on the equator,
you're
not going to cut it that way.
No, but I can be looking that way. I can be looking.
Yeah, but you're right. Okay, so
and measure things that way, right? So,
but you're still on the sphere. So if you were to erase all of the continents and everything, you're still on a sphere. You're standing on it. Down is towards the center. Down is towards the center. There is no other down. It's always towards the middle. It doesn't matter where you're standing.
No, that's not what we're talking. You're kind of missing what I'm saying, though. I'm not talking about that. I'm talking about your line of sight. Okay, your line of sight.
Line of sight on a sphere. It doesn't matter where you're standing. It's all going to be the same.
It's not though. It's not. And this,
it is, because a sphere, in any direction you go, that's the whole point of a circle and a sphere.
But look, we take the sphere and we take the sphere and we cut the sphere in half first, right? So right at the equator,
cut it in half.
Right. So right at the equator, we're around here. We're 25. Yeah.
Yeah.
Okay. So at 25,000 miles, you're going to have a rate of curvature, right? But then if we cut off here, which is only 12,000 miles, say Antarctica.
Why are you cutting it off there though? I don't understand. What you're not. That's.
It gets into flight paths and stuff like this, right? So if you're going this way around Antarctica,
the path of the geodesic is always around the center of the sphere. You form a circle around the center of the sphere. That's your flight path. So what I'm trying to say is, I get it. You're on Antarctica. We're on Antarctica.
I'm gonna move on from that because it's not going anywhere.
But I'm trying to comprehend that. I guess.
I know. I'm just saying it's kind of hard to explain when I'm fighting the kid.
Oh, I know. How old?
He's like.
How old is he? Oh,
18 months.
Nice. Yeah. Snuggle bugs.
But so two separate circles, just circles,
Yeah,
take these
if
two
you were to
circles,
draw a
right?
circle,
Going around this small, right, is a shorter distance.
yeah, it's a shorter circumference, 100%.
Okay, so that means the rate of curvature increases because the circle is smaller, right? So this circumference is 25 miles. This circumference is only 12,000 miles. So but this rate of curvature it increases. So if you say the standard rate of curvature at the equator is 8 inches per mile squared, and not arguing that, I'm just saying if that's like a standard, then this was going to be like 14 miles squared or whatever, right?
Yeah, but
Because
see, that's not how. Yes, it's a smaller circle on the sphere. You're drawing a smaller circle on the sphere, but that's not how being on a globe works.
Well,
Because
if you're on I mean if you're on the equator, right? Your circle
yes,
of the equator is 25,000 miles. But if you're
no matter
on
where
the
I'm at right now, where I'm at in
80
Boston, if
degrees
I
north,
draw, uh-huh,
no, I know what you're saying. You're saying perpendicular all the way around the globe. It doesn't matter. And I agree. That doesn't matter. That's not what I'm saying. I'm saying something different.
yeah, but that's
I'm
what.
saying
Yes,
if you travel on the 80 degree north parallel, right? The 80 degree
right.
north latitude parallel, you're traveling
It's a
at
shorter
a
circle.
significantly smaller distance, right?
Yes.
And if you were to calculate that distance that you travel in a arc, in a curvature rate, the rate of curvature increases significantly because you're out of a smaller circle.
But that doesn't change my perspective of
It's the
standing
same
on
thing
it
with
and it's still being a sphere. Yeah, sure. If I were to draw, if I wanted to walk around the Arctic Circle, as cold as it may be, but just follow that line, the Arctic Circle, it would be a much shorter circle than walking around the equator.
Okay.
100%. I
So
agree with that all the way.
that circle that we're talking about has a greater rate of curvature. And just so I can get to the next point, that circle has a greater rate of curvature, meaning that it curves way faster, right? The inner circle, the small curves way faster than the outer circle.
Well, no, it
So
curves the
80
same. It would still
but it
curve
doesn't.
the
It's a different
same.
size circle. It's a different size circle.
So it'd be the different size circle that I am traveling as the person, but from my perspective, either way I look, either direction I'm looking, it doesn't change the curvature because I'm still on the sphere that is still the same circumference. Just because I'm going in a different direction and I'm walking around the Arctic Circle, it doesn't. The same sphere is still under my feet, is what I'm saying.
I understand. I get it.
And
This
in order for
was
me to get
something
back to
that
that same spot, in order for me to get back to that same spot where I started, it would be a smaller distance, 100%. But that doesn't change the shape of what I'm standing on now. It doesn't turn
but it
into
changes
something completely different.
it changes the rate at the curvature rate at which is
So then, okay, we keep going up. We keep going up, and we get to the North Pole, right? And then there's a point on the North Pole that there is no all the longitude lines meet. There is no latitude line. I could just do a circle right there. But I look around and it's all still the rate of curvature because I'm still on the very same sphere. I'm just traveling a shorter distance. That's just how I'm traveling. It doesn't change the shape that I'm on though.
All right, let's if you were to calculate the rate of curvature for the outer circle, is the rate of curvature going to be different if you calculate the inner circle?
No.
So this rate of curvature, they're going to both be the same.
On a sphere, yes.
No,
if I'm drawing a line
on this.
Yeah, but that's a circle. If I'm a two-dimensional being standing on top of the small circle, 100%, that would be that the curves at a much steeper rate than the actual outside drawing. Yes, 100%.
Yeah. So if I had a basketball and a tennis ball, is the rate of curvature different from a basketball than a tennis ball?
One of them's bigger than the other. They're both spheres. They're
Yeah.
both.
So what I'm talking is not sight, right? So I'm not talking sphere. I'm talking a line of sight. That's where I'm trying to go with this, right?
Yes.
So if I'm
yes.
if I'm on a ball that's
If I
the
was on a
size
tennis
of the
ball, I
outer,
would be able to see not as far because it curves much quick. It's curving much more quickly because it's a
well,
smaller
you'd be able to
sphere.
see
Yeah.
further, right? You'd be able to see a lot further.
No, if I was on a basketball, I'd be able to see further because it's bigger. Whereas if I was on a tennis ball, it's smaller, it'd drop off much more quickly. I wouldn't be seeing anything beyond it because it'd be dropping off.
Yeah, right.
The bigger it gets, the farther I'm gonna see.
So your line of sight is a straight line distance, yeah?
Yeah, and it's increasing the bigger the sphere gets.
Okay. So if we were to take just on my circle here, right? If I was to, this straight line distance here, from here to here, there to there,
Yeah.
it's backwards, right? So it's going to be a shorter distance than if I complete that line all the way out to the end. You know what I'm saying?
Shorter.
Hold on.
And that's yes, and this is a.
So if I'm measuring the line of the purple, right?
Mm-hmm.
That's a shorter
Yes.
distance than if I was to measure the line. What I'm talking about is line of sight, okay? And that's what I want to get at.
Absolutely.
If I'm at a point here, right, and my distance to line of sight is here, right? But on the ball, I should only be seeing to here. Lobe, right? I should only be seeing this purple, but I actually see over here to this orange line. My line of sight is going to be the length of my line different on a smaller circle
that doesn't
than it is on a bigger circle.
on a circle. So it doesn't change on a sphere though. If I'm on a sphere, my line of sight, no matter where I'm at on the sphere, it's still going to be the same.
Well, the longitude lines are circles.
Yes,
a longitude line and a latitude line is a circle.
But yes, they both are. Whereas the longitude lines are all even circles, they're all the same size. They all intersect with the other one behind it, and the latitude ones are the ones that get smaller. So you might not be at a latitude.
If you travel on a constant latitude line, right, you're traveling a lot shorter distance.
100%.
On the northern or whatever, it doesn't matter.
Northern or southern, because that's how the latitude goes. They north, equator, then south. That's how they go. And if I'm doing a circle, 100%, I agree with this completely. But
okay, so
my point is, it doesn't change your line of sight. Your line of sight doesn't change because of that.
Okay,
why would your line of sight change?
So if I'm looking at something from 120 miles away, and I know. I try to keep him off, but he's climbing all over me like this.
Is there anybody else watching?
No, just me and him right now. Sorry.
Here's Daddy.
No, you're good.
So my line of sight from the seven states deal, right? 120 miles away, but the curvature, the rate of curvature, or the curvature of the Earth, the physical bulge of the Earth should be at 50 miles. So if I see anything in that shaded area that I shouldn't be able to see, then either the rate of curvature is wrong, right? No curvature. So how far can I go before I say there's no curvature?
There's a lot of things that can be wrong with that, though. There's a lot of things that are wrong. It's not just that the thing is bigger. It could be there could be some math being done wrong here, and that's
so forget all that. But how far do you think I should be able to? How far away should I be able to see something before you say there's no curvature? What would you think? 100 miles? 200 miles.
500, honestly, 500 miles. If you can show me
So
from
we should
Dallas
be able to
to
see
Vegas or
500
something.
miles. So we should be able to see 500 miles of no bulge between us on the Earth.
I'm sorry?
Like, okay, so the rate of curvature for the Earth,
No.
given the numbers, we're just accepting, and we're using that as our base, right? So the radius of the Earth is 3,496 miles. We accept that the Earth is 24,901 miles. We accept all the numbers that they give us, right? We accept that it's an oblate spheroid and not an actual, perfect sphere.
Well, yeah, nothing's a perfect sphere. Nothing is a perfect sphere. It is 27 miles wider at the equator.
Yeah. So we add stuff, and then we actually test that rate of curvature. That the sphere, whatever we accept it to be, has to have a rate of curvature, and it has to have a distance to where the physical horizon is blocking our line of sight, because line of sight is a straight line. It's not we don't see around corners,
No, 100%.
So
atmospheric refraction, it's certain things that happen over moisture,
well,
things like that. Absolutely.
Atmospheric refraction will be a whole different conversation. But what we're talking about is the physical line of sight.
Physical line of sight.
I can't see through my wall. I can't see
100%.
around the corner. I have to have something to do that. So
it's actually on the other side of the moon.
Feet, 1,700, whatever the math you want to use, right? It's going to come up a line, a physical spot, a physical distance to where
and that's what happens.
Curvature
That's
of the
what we
Earth is going to block the line of sight. Okay,
that
so
what we observe.
At 3 miles for standing on the beach, that's when the physical curvature of the Earth happens at 3 miles. But I can see
not that everything drops off. Not that everything drops off. 3 miles.
Everything in that shaded out. Everything in that shaded area. We're not talking about anything above the shaded area. Only things in that shaded area.
Yes, which is why the bottom of the boat disappears. Absolutely. That's why when a boat goes out, it disappears from the bottom up.
But the bottom of a boat can disappear for a different reason. We can get in it.
Or
I'm talking about things that I can see
in the
shaded area. The what?
The helicopter. The whole thing with the helicopter. The helicopter went down underneath.
That fake video.
We reject that. Okay.
We get into that later.
Then how do I know your Georgia thing is? See, that's not fair. That's not fair at all.
No,
you can't.
Because
and that's why I'm trying to stay away. Like the numbers can't be manipulated on the distances we can see farther away. So I'm not in Georgia right now.
All I'm saying is
I can't see that
shaded area. I should not be able to see.
No,
100%.
No. Okay, it'd be a little different because it's not a two-dimensional thing. That shaded area is more going to be.
So if there's something in that area that I can see, I shouldn't be able to see, then okay, we can wrong, but we can keep doing the math over and over again, and it keeps coming up the same thing. Anything inside that shaded area, I should not be able to see. I do see.
But see, I haven't seen the math. I'm definitely gonna look this up though, and I'm gonna. There's no math being done right now. Me and you aren't doing any math right now.
Oh no, for sure. I have a calculator.
For me to say, and then, but yes, but so you choose to trust that, but you're not choosing to trust the information that's coming down from the ISS.
No, yeah,
but that's
because one is tangible and one is not. One I can measure.
No, you're picking one to be tangible. You're saying I trust these equations, I trust these formula, I trust that I shouldn't see something at 3 miles an hour because they said I shouldn't, and because it's fitting what you want, you're accepting it.
No, I don't. That's the thing. I don't. Rate of curvature.
If we
is
see
not
too
my
far, that's a problem. That's a problem. And sure, I will, like I said, definitely look into it. But there's too many other things.
So I'm wondering
that tell us we're not on a flat.
yeah. So we could go to,
From the tip of Everest, you're not.
if we
like,
took a vacation,
I-
you and me, we could go to over here with all of our equipment, and we can look at the seven
watching
cities.
the sun,
Not
watching the
seven states.
sunset behind a building with a solar filter, like on a telescope, that's not possible. It's that the only. I'm not going to sit here and say the only way that can happen is on a globe, but the only way it doesn't happen is on a flat Earth. That's for sure. The sun doesn't go from being
Yeah,
above
so-
everyone's head on a flat plane to all of a sudden it's coming down to where I can see it behind a building. Perspective doesn't explain that.
There's multi-facets of perspective that do explain it. All right,
But
so
no,
so
where
for instance,
where does perspective say the sun's thousands of miles up, but then it's behind a building that's a couple miles out?
right? So, well, basic perspective, like if this is the sun, right? And
Yeah,
it looks
it's getting smaller
getting
it's going
smaller
further
here,
away.
right? But
Which the
if
sun
it
doesn't
doesn't
do.
move, if it moves distance away from us, right? If it stays at the same distance, if I do this, right, it's the same distance, yeah, from the camera.
Yes.
But if I do this, it's a different distance. Okay, so now let's at fixed distance. Just saying it, the background. Okay, so now let's say this is a building, or this, right? Now this can you see the sun?
No, but you just put
Can
the
you see the
building up
sun?
in front of it.
Okay, but did the sun size change?
The sun size change.
Did the optical sun change on this, right? I'm not moving the sun closer or further from the camera, yeah? I'm gonna keep it right
Yes.
here. Okay.
Yep.
Okay, so now I have whatever, a building, and the sun is gone, right? Or a lake or
Most
whatever,
of it,
right?
yeah.
So
The sun's gone, 100%.
ignore the
But
stuff
that's
below the
because of the
paper.
distance.
Okay, so but this is let's say this is it's a fixed distance. This isn't coming in and away from you. It's just going around. Okay, same distance. Okay, so now you put something in front of it, and this distance hasn't changed, but because your perspective changes, you don't no longer see the bottom of the. Man, I can't do this backwards stuff. It's hard.
What,
a building or whatever. Yeah, and so the building is closer to you, right? And it
Yes.
blocks out the sun.
But
But
the
the
building
sun's
isn't
size
moving.
has never changed. No, I know.
But see, the building's not the thing
My hand
moving.
is-
So I'm standing still. If
No,
I
I know. I'm
sit
just using
here
it as
and
an
I
example,
know
right?
yeah, but that's not what the sun does. That's not what we
No,
don't.
What I'm saying is the sun is in the background, right? And it's relatively to you, the sun stays the same distance. Okay. And that would be this, not okay. So the sun in the background, just like all the stuff in the doesn't change in size because it's not moving away or further from you. Okay. It's only moving around you. Okay.
Okay, but
So it's
isn't
staying
that
the
what
same
they
distance
say is
from
the
you.
sun is happening? Isn't that what they say the sun is doing on a flat Earth? That it's moving away from one point, it's circling above us, moving away. Isn't that the commonly accepted
Yeah,
model?
well, yeah, like move your position. Yeah, but not in distance, is what I'm saying.
Yeah, but it is in distance
When-
because if the sun is
What I'm
overhead
saying is
over
when
the
you
equator,
observe the sun, right?
Mhm.
Setting. When you observe the sun setting, it's doing this and keeping the
yeah,
same
but
distance
a
from
couple
you.
hours earlier, it wasn't setting and it's over my head. 12 o'clock
No,
noon,
yeah,
it's
that's
over
what
my
I'm
head.
saying. This would be like a top view of what I'm talking about right now. The sun doing this would be like a top view or a looking up
Okay.
view. And it's the same distance from the center point. It's not changing distance. It's not doing this. The sun's not doing this. Like the sun setting like this, that's not necessarily. Oh, I'm saying maybe that's not necessarily what the sun is doing. Doing this. Maybe it's doing this, right?
But then
I-
that doesn't work on the model. Yeah, it's doing a circle. If I'm the camera and I'm looking up like at the ceiling, the sun, and then behind it are the stars, it's moving around in a circle, but that doesn't explain it would get smaller. That's just it would get smaller in the sky because it's moving away from me. Okay, it's over Boston right now. Now it's heading, over the Midwest and it's heading out to the West Coast.
Yeah,
It's getting
right.
smaller from where I'm at, but it doesn't. It doesn't get smaller. It stays the same exact size until it goes over the horizon.
And what I'm just proposing something that might be a possibility is that distance wise, even though it's going over the horizon, going past the horizon or whatever, it's not changing in size.
It doesn't change.
Because it's not
Going away.
changing in distance from you.
You're right.
It just
Well,
looks
see,
like
that's
that.
the thing. Yes, you're 100% right.
It's already
You're
it's
absolutely
already at
right.
it's already at its focal point from you.
Well, it's
I-
already at the fixed
I
distance.
have a way
We're
to
the ones
explain it.
spinning. You're right.
we
It's
got-
not moving. The sun isn't moving. We're the ones moving.
No, it is. The sun's moving too. So in the heliocentric model, the sun's moving 3 different directions by itself.
Well, yeah, because we're moving around the galaxy with it.
Yeah, so the sun is moving too. It makes no sense because we see the same thing every
Just
year.
because we can't understand it doesn't mean it's not true.
Hey,
Mandarin doesn't make sense to me, but it doesn't mean it's not factual conversations that are being had in Mandarin.
I know, but you could learn Mandarin, right?
And we can learn physics. We can learn these things. We truly can if we're like. And like I said, I'd like to be open-minded. But if something's not making sense and it doesn't add up, that's just the way it is.
I was just trying to give it a demonstration. I mean, we jumped to the sun because I was trying to get to something else, but the sun. I'm just giving maybe a different explanation. The sun's not moving in away from you in distance. It's moving away from you in distance. So you can have something in the background that is going to be the same size, and something in the foreground actually come to a point.
But because we're not just one person and we have multiple people all around the flat earth, the globe, what have you, we know that that's not the case. That for me, yeah, sure, it might be setting, but for somebody else, it's rising. And
well, yeah, because they're looking at it from a different perspective. So,
which brings me back to the moon. It's an object that one person is seeing one way and someone else is seeing another way. That is impossible if we're all flat. If
but yeah, I mean, you can look up at the ceiling light from different sides of your room in different directions.
Yes, 100%. 100%. But that ceiling light's not moving, and I'm the one moving. So if that ceiling light were to move, I would see, okay, look, there's the other side of the ceiling light.
You can still move the ceiling light, right? If you made the ceiling light to be movable, right? And then you looked at it from one side of the room, and then I looked at the side of the room, where it's at in the position right now is going to be different orientation to both of us. Then we can move the moon again, and we're still in the same position that we were in, and it's going to be in a different orientation. So the orientation changes as the moon changes, right?
But so would our vision of that light, and we don't see the moon from any other side. We don't see another face of the moon. We don't see the side of the moon. But if we're in a room and we got something hanging, one person looking at it from the other side would see a completely different side of it. And that's not what we observe.
Well, yeah, but I mean, even this here, like if this is our light in the ceiling, right? And this line is vertical here, but I'm standing up here in this part of the room, it's going to be horizontal, right? And then
yes.
If the moon moves in that same room, the position is going to change, and we're going to see it still from different positions, even though we haven't moved
but now
in the moon.
Now the shape of it will change, though. Now the shape of it's going to change because, especially if it's something flat like that, we will be seeing it at a different angle. It'll distort shape.
No, we never see anything. We never see anything other than that one face of the moon.
No. So if you do that with the globe right now, and if the globe that you have there, and if you were to hold up that globe and say, I'm standing from one side and you're standing from another, you would be able to see different continents than I'd be able to see.
So
Right.
the globe, right?
Yep. And even if you
Yeah.
put it high above your head, I'd be able to see different continents than you'd be able to see, but that never happens. We just see it flip. We
Yeah, and
just
that's what I'm
see,
saying. This just flips. That's all it
yes,
does.
but
I mean,
but if it's up on the ceiling and you're looking up at it,
okay, so this is this is a okay.
yep,
And of course this is going to be general here. And this is Australia.
yep,
Okay. And so like I was saying, like me and person in Australia can see the moon at the same time. Okay. And
hmm
so maybe the moon way out here in order to see that. Maybe.
yeah, it
Okay.
is. You can fit 30 Earths in between the
Maybe.
moon and the Earth.
So if I can see the moon, but the problem with that would be your curvature of the Earth would get in the way, so you couldn't see the moon.
No. Hold your piece of paper way out. Hold your piece
I know
of
it.
paper 30.
I
Put
know it.
30 of those
Yeah.
globe distance out.
Yeah.
There you go.
But that's a speculation because you can't
That's
measure
not
that.
speculation, though. We can measure.
Yeah,
We
it
have
is.
measured it. You can go to any university and measure. You can
Oh, I know,
send
but
a signal to the retroreflectors.
No, that's never been shown. I've never seen
It
that
has
happen.
been shown. You can
No,
you
I've never
can
seen
go
it actually happen.
to where the hell, Juneau or wherever they University of they got you can. Okay. All right.
I know the argument. I know the argument, but the University of Alaska here in Fairbanks Observatory, it's never been shown to happen.
They
But that's to me
all right.
that's irrelevant anyway because we're not proving the shape of the Earth, proving that we can.
But that
shoot a
does prove
laser
the
in
shape of the Earth,
sky
because if
and it
we can
returns.
tell the distance, if we can tell the distance between the moon, and you have that as concrete, oh shit, okay, this is the distance from here to that object. That is showing you why we see it that way.
No, I've done the like the equation. I've looked at the equations and stuff for it too, and it's based on an assumption. Again,
What assumption?
The equation itself is based on the assumption.
The equation for what, though?
To measure the distance to the moon. It's just plugging in. You just take an equation and then plug in a variable, and then that's what you get. But if you change that variable, then the equation changes. Then the distance to. So you can put in there any variable you want in the equation, because it's just based on the variable that you input, not on an actual measurement.
We have actually measured it. And it doesn't change.
But I mean, that's something, we're talking, you're not showing anything too. So it's kind of like,
I know I can't really do it on my phone either.
It's kind of a disadvantage for us to do that, But okay, so I was trying to get at line of sight. How far would a line of sight be that would say there's no curvature, right? How far would that, how far would you want that to be?
Yeah, you show me something 1,000 miles away.
Well, yeah, but
no curvature.
But that's not.
That is possible because we see the moon even on a flat Earth.
But again, you're going back to saying that the moon is a certain distance. You can't prove that to me.
We can prove that it's what we can prove is when we see it overhead that it's extremely far. We see planes fly under it. We know those planes fly, right? We know those planes fly at 30,000 feet, relatively. Depending. I don't know. I guess for me, the only way to accept it would be to, if I could see something 1,000 feet away, if you could show me the firmament, absolutely.
Well, I can show you like things about the firmament, but I couldn't actually show you like the.
And I was looking up. There's been videos. The sun in Antarctica. There are videos of 24-hour sun in Antarctica. After we've
discussed that, and the videos that are in the Antarctica 24-hour sun are manipulated. There's only 3 of them. It comes down to like 3
No,
videos.
no, Nat Geo was
Videos are
there. There are
manipulated.
so many more. Based on what? Now you're just saying that though. That's completely
No, like clouds being the same, they're being on a repeat loop. You know, it's not
because it's
the
a
same.
camera
It's the
spinning in
same.
a circle following the sun.
No. Over 24 hours, the
Okay.
clouds don't. They're not the same clouds in reality, but they're the same clouds in the video.
In December, what? All right. So what is going to happen if they show you a 24-hour sun in December? Both
makes no difference.
flat earthers.
It makes no difference. It makes no difference for me. It only makes a difference for the globe if there is no 24-hour sun.
But there won't be. That's
What?
There won't be.
If there is
I
no
put my
24-hour
life
sun,
on it.
if there is no 24 sun in Antarctica, then that ruins the globe. If there is, it doesn't do anything for me. It doesn't change anything.
But do you not see how that is not stepping out of looking at your own ideas and trying to rigorously test them to see if they're
because
true?
what I'm saying is, and I've given you that. Go hand these videos and just explore them, because you can demonstrate that there's a 24-hour sun. All I'm saying is that the videos that they use to say that there's a 24-hour sun, I'm not saying that there's not a 24-hour Antarctica. I've never said that. I'm saying that the videos that they use are not legit. Those are manipulated videos, and we shouldn't use them. If they're 24-hour sun, it doesn't make a difference. It just means that the light is doing something that we don't understand.
Well, it's not the light. You can't just say it's light because you'll be looking at the actual sun. You'll be looking at the same sun. You can go down there with solar filters and see the same sunspots, albeit they will be inverted because we're looking at them from a different perspective. The same magnetic field, the same auroras that happen down at the South Pole because that's where our magnetic poles are. How else do you explain the auroras? If not a magnetic field created.
The auroras are gas and an electromagnetic, yes. But
yeah, they're the sun interacting with
that. And something interesting about you can manipulate them with sound. Like you can get them to get them to dance. You can like get them to dance when you whistle and stuff at a certain pitch or frequency. It's kind of cool.
Okay. I could totally see that. I mean, because what is sound after all except for the vibrations of the atmosphere around us?
You know HARP? You heard?
Yes, I've heard of
HARP, like
HARP or HAR. It's the. I know it's the whole. Yeah. It's up there by you, and
they can make auroras. Auroras.
Yeah, because they're making their own electromagnetic like field that's interacting with the sun's particles. I think that's what's happening. I know that's how the auroras are made.
They can make auroras anywhere, and they have.
Yeah, but they're not this
all over the U.S.
They're not this. Those were from
check out
solar activity.
Oh no! Like they're producing the auroras with the machines.
Yeah, but no machine can make it. I saw them here in Boston. I have pictures.
Yeah, and that's not normal. That's not normal, right?
No, but it's not. It's not completely uncommon because the sun has its phases where it does this. They knew they were going to happen.
If they can generate.
Well, you can believe that they can generate that, but you don't believe that they can get into orbit.
Well, no, they don't
have
believe they can
that
get in orbit.
They are in orbit. They are. Because you cannot. We can determine the speed.
Can you see the
ISS? You're never going to get me off this because we can see it.
I know, but a lot of the things that you bring up are like things that are hearsay. Because
the ISS is not hearsay because it goes overhead. It goes overhead.
No, I know, but it's because what I'm saying is you're going off of things that you're told, not that you can verify yourself.
No,
to-
so, okay. So if
and
you
again,
really
the
wanted to,
ISS
me and you
could
can
just-
track the ISS with
the
a couple
ISS
more
could
people.
just be 10 miles up because
No,
it's the
so
same
you
size
know
as
what?
the
We can do
plane,
this.
and it
We
appears
can
to
do
be the
this with a
same
couple
size as
more
the plane
people.
at 10 miles.
With a couple more people, we can track the ISS all the way around the globe. We could get someone out of Australia. We can literally get people, and we
But-
can time it. It takes 90 minutes to
Yeah, it
do a
doesn't-
full orbit.
But that doesn't even matter though, because you don't know your distance.
Why?
So
No, but what does matter is if it goes from one, if we're measuring the distance and the speed it goes around, and it comes back in 90 minutes, that does matter, because those kind of speeds aren't possible in the atmosphere. Like that's no question. That's no. Also, okay, the
yeah,
atmosphere. Why do we have a gradient?
again, you keep
Why do we have a gradient in the
you
atmosphere?
can keep talking.
Why is the
Well,
pressure
from a
not
flat
equalized
Earth
all over the
perspective-
place?
From flat Earth, you have to have a container to show a gradient to begin.
No, because if you have a pressurized
You can't
container,
have
it's equal pressures pressed all
without
along
a
it.
container to demonstrate that in.
You
So
can't have a
then,
what?
so
I'm
then we
sorry.
go back to the firmament. The firmament would be a container.
Yes, but then the pressure will be equal along the fluid.
Do
It
you-
wouldn't
do
matter
you
what
think,
height you're at.
Well, gases are inadvertently different pressure than each other. You know,
No, they're different densities.
yeah, different densities than each other. So
And
so
what-
that creates a gradient in itself.
But why? If they're different densities because some of them weigh differently, and they weigh differently because of gravity.
Okay, all right. So gravity causes what type of gravity are?
What do you mean? It's just the gravity that we experience. Newtonian, it doesn't matter. It's the gravity we experience.
No,
I
it
drop my
does.
phone, it falls.
It does because Einsteinian gravity refutes Newtonian gravity. So
How?
is it
Where?
the mass
Where?
of the Earth pulling it to the center? Because you can't demonstrate that at all.
Demonstrate.
You can't demonstrate mass attracting mass in Newtonian gravity. You can't do that
What? Of course, because you don't believe the.
because you would have to have something. You would have to have you demonstrate it. You have it on a cosmic scale, and that's not a demonstration, right?
I
So-
know, and you don't
Demonstrating
believe
anything.
the. Oh my God! Why can't I think of the name of the damn experiment?
Can you see
with-
the comments
with
at all?
it. No, I'm not on YouTube.
I wrote a couple comments, but I don't know if they
So-
went through. So
trying to think
again,
here.
I I always try to get back to the tangible because we're talking about things that are not tangible.
Yeah, but you're
in the
not.
sense of
All right, you tell me what's tangible then.
how far you can
I
see.
gave
is
you the
tangible.
moon. I gave you the. But again,
No, how far
I'm
you can see
telling
on
you
the
both
Earth. How far
disappear
you
from
can
the
see on the
bottom
Earth is
up.
tangible. I can measure it.
Yes, and I'm telling you both disappear from the bottom up, and I've seen it myself. And you say you've standed on a much higher elevation and seen farther away, which, yes, that would happen.
I
Because
tried to
you're up
explain
higher.
that to you, but I tried to explain how that works, but
So
we were just going kind of circles. Something in the background stays the same size relative to your location because it's not changing in distance. And something in the foreground, as it gets further away from you, it does shrink because it's in the foreground, and then
it doesn't matter if
vanishing
it's.
point. But the sun is in the background, so it's not going to change in relative to you.
It's not always in the background, though. That's the problem. The sun is not always in the background. It's constantly moving.
Well,
and
even in the globe,
people
even if your globe model, it has to be in the background.
Yeah, because we are spinning, so eventually it gets to that point, and that's the only reason it
Let's
drops
go.
that low is because
And-
it's going
and
below
by-
the horizon.
In perspective, you have a foreground and you have a background, right? And you have where in the foreground perspective shrinks in size as it gets further away from you, and that's
Yes, there's
that's gonna
further
be a distance.
differences. Yes,
And then,
there's
so
further
if there's
differences
something
in
larger
smaller
in the
spaces.
background, like a mountain, it's because it's not changing in distance from you.
No, the mountain's not.
Yeah, so it's not going to shrink because it's larger than the perspective.
But if I'm moving away from the mountain, it will eventually shrink.
Yeah,
If
but
I'm also
in a
if I'm
still
also
photo,
increasing.
in a still photo, or even in a still video where you're taking a video of the sun, and there's a mountain there, that mountain's not going to change size.
No, but the sun would if it was actually moving away from us, which is what the flat Earth model says it's doing.
Moving away, but not necessarily in a significant distance. And that's what I'm trying to demonstrate, is that the sun may not be moving away from us in a significant distance.
The whole circuit of 25,000 miles around the equator at a certain time of year. The Tropic of Cancer, the Tropic of Capricorn, it does that whole circuit, which is bigger in the southern equator, in south of the equator, because that's how it would work on a flat Earth. Instead of the Tropic of Cancer and the Tropic of Capricorn being the same size, which they are, on a flat Earth, that doesn't work.
They're not the same size.
They are the same size, maybe slightly.
Flat Earth, on a flat Earth model, they're not the same size.
No, of course, but I know that. But in reality, they are the same size, because if you were to travel the Tropic of Cancer and go where it goes, it would take you the same time to go around the Tropic of Capricorn. Or I think Tropic of Cancer is in the south.
It doesn't matter. I know what you're saying.
I know it's the same size, but on a flat Earth, it wouldn't be, because one of them's a bigger circle.
Yeah, where is that at? Where has that been done?
What do you mean? Where has it been done?
Traveling along the Tropic of Capricorn. I mean, you have to go from land to sea and sea to land, so it's never actually been done in one consistent circumnavigation.
I mean, saying that doesn't mean it's true. Just because I don't know anybody else in the back of my head that's done it doesn't make it so.
No. I'm just saying where.
But in order to measure distance, like Australia is along the Tropic of Capricorn, so that would mean the sides. Like, you could easily measure that from one place to another on Australia, and you can scale it up with the Tropic of Cancer in the north and measure it. But on a flat Earth map, since the Tropic of Capricorn is outside of the equator, it's much, much larger.
So there's testimonies of people.
You can't say testimonies if you're not going to take anything from NASA. You can't. So you can't say these people have said that it takes me longer here if you're not going to take the word of any other actual referenced, tested scientific studies.
Yeah. So a lot of different things, and I'm going to keep going back to what.
I know, tangible.
It's what I can validate myself. The moon is not tangible. I can't validate it myself.
No, but we can see the face of it, and we can see that it flips. No matter where you went on a flat Earth,
but that's
the face of the moon would not flip.
So what would it take to, I can't show you the firmament. I can't show you space. Nobody can show me space. They're not going to pay for space. They pay for people that go up to space that's going to follow their narrative, like the Red Bull guy.
Felix.
What can we do? What can we do as low lifes that are low on the system to prove it ourselves without all the stuff that they tell us? So what can we do to prove it ourselves?
And like I told you, my answer is definitely going to be the moon or the constellation. Seeing constellations that I don't see up here.
I keep saying that you can't prove the distance to the moon to me. You can't do that without the help of some institution.
No, I can't. It doesn't matter the distance of the moon, because on a flat plane, it wouldn't work. On a flat plane with the moon circuiting above, because it's a circuit or whatever, you wouldn't see the face rotate depending on your latitude. It just wouldn't happen.
That's easily demonstratable, even in your bedroom. You can
no,
rotate
it's not.
the moon around your ceiling. It can change orientation.
But then I would see different. It wouldn't just be the orientation. I'd be seeing different sides of it at that point, because it's only above me, and it's.
Well, you're assuming a ball. You're assuming a ball moon again.
Well, if it didn't move, if it stayed still, I wouldn't assume it. But seeing as how we
No,
see the
not
shadow
not
cast off of
movement.
it, we see craters on it.
Uh,
We see all of it.
I'm saying you're assuming a sphere moon, not a. It could be something
is.
different. It could be.
I'm not assuming. What could it be? Please propose to me something that would work, that would cast the same shadows that the sun shining on it would illuminate
Well,
it.
yeah, you're saying shadows again. That's why I got into the conversation with the other guy. Is like I kept saying, validate that it's a shadow. Validate that
We can see the shadows of the craters. We can even measure the shadow from the sunlight in the craters. We can do. There's math that can do that because you can see the shadow being cast. You can tell how deep a crater is.
Yeah, but you can't tell me that. That's how deep it is. You can't physically measure it. You can't physically measure it. You can only use an equation that requires an assumption to come up with an answer for the shadow of the moon or the craters or anything, because you can't measure it.
Okay, and I can't sit here and tell you I know the calculations, but they have been measured.
No, I know the calculations. You're taking an equation, right? A plus B equals C, simplified, and you're putting in a number to A and putting in a number to B to get C, or you'll never get C. You have to actually put a number in, and they're just putting a number in. What if that number is wrong?
No, they're not just putting. They're not just
It's based on an assumption. They're assuming this.
Things start with an assumption, yes, but then you test it. Oh shit, these numbers don't work. Oh no, these numbers don't work. Oh, these work perfectly. Like eventually you get there. Eventually we get there. That
again,
and we got
again. You keep going back to.
Yeah. So okay, what do you want me to say? Right now, there's nothing I can do. I can't prove. You can't prove I'm standing outside right now. Like, see, that's what it's turning into. And that's
it's either
an
accept what you're told or do something yourself. Accept what you're told or do something yourself. I want to do something myself.
And me too.
Validate. But nobody shows me anything that they can do themselves. You can't validate the craters on the moon by yourself. You cannot do that.
I can see them. I know what a crater looks like.
You have to use the narrative or what is given to you in order to validate that. You can't validate that yourself. All you can do is observe.
Do you know what a crater looks like, right? You know what a crater looks like.
Yeah, and no craters from any trajectory of any kind of impact look like that.
They're all over the moon. What are you talking about? Yeah, no, no.
I can do a crater analysis on every crater of every artillery round that is ever fired. A distinct pattern, right?
Yeah,
and every pattern is. But there's only one pattern on the moon, which is pretty round, pretty circular.
It's just like when you're in an airplane, you look at fields; they look the same way because of how far we are.
It's not consistent.
When you get down to it, they're not that perfect. When you get right up close and personal, they aren't that perfect. Just like everything looks perfect from a higher altitude, but once you get in, you see the detail. There are craters within craters within craters too. Like the
stuff all over the place. No, so again, I'll bring it back to being what you and I can do, and staying away from the proper, right? What?
Yeah, but it's a visual thing, I guess.
Measure and test actual craters. I can't do that with the moon, so it's not tangible to me.
But you can see what? Okay, then let me ask you this: what are they? What are you seeing when you look at the moon? What we call craters on the moon. When you look at the moon?
What do I think they are?
It doesn't matter. Craters, shadows. What if it's not a shadow? What is it?
Yeah. I don't know. I don't know what they are because I can't physically test it. That's what I'm saying.
Then how? But see, if you're somewhat based off scripture, then there's so much in scripture you can't physically test. But you seem to accept it.
Well, that would be faith. We're not talking about faith.
You're right. You're right. But from your faith, you're deriving factual firmament about the world. So that's that like
Right,
you're
but if
combining
you
them, but
have,
then you're saying now they're separate.
but what we're talking about then is, you know, separating the separation of two different models. On the globe model, there's no firmament.
No, there is no firmament
On the
because
flat
things
Earth
come through
model,
all the time.
well, again, I go back to that same thing, because you're saying that things come through or things hit the Earth that are asteroids or meteors or comets or whatever. I want to see the crater analysis done on it and know that it's not a trajectory from some round that some military has shot off.
No. And you can do that because there's ones that hit all the time. You can literally see things fall through the night sky all the time. You can look it up. There's like a whole website, I'm pretty sure, about it, where things land. You
Yeah, I
can go
know. You
find
can
these
see
things
stuff in
yourself.
the sky that is moving in the
No,
sky.
no. Yeah, and then sometimes they hit near where you're at, and you can go find it. It's not like an unheard
Yeah,
of thing. People
that
find
doesn't mean it came from that doesn't outer space. It might have came from that National Guard unit down the road.
from that, but why would you accept that? It just came from some random person. What the? I don't understand. I don't see the. So
Well,
I
all I'm
understand the not
saying,
trusting the
all I'm
government.
saying is bring intangible instead of bringing it back to the storyline. So the
So
storyline
there is
is well
tangibility, and there is
birthed.
a science that can tell you how old, and like there is science that can tell you these things. And just because I can't sit here and explain it doesn't mean it's not real.
No, I don't reject what you're saying because you can't explain it. That'd be ridiculous. Because then I would
Yeah, I
have to
know, because
expect the same
we're
thing from
talking
you.
through an app that somebody beautifully coded to somebody made a camera that we can see each other right now over thousands of miles away, and that these are
Can,
the same
can
people that are doing this.
let me ask you this: can you separate yourself from the narrative?
Yes, without any narrative, me being
Because
in this spot, looking at the sky and
because
going to a
it
different
doesn't.
place and seeing a different constellation has nothing to do with anything I've been taught. That's a
Well,
visual observation
your
that repeats
to begin
itself.
your starting point, right? Is part of the narrative. Your starting point is saying it's a globe, so therefore it works this way because I was taught
No,
this
no,
way
no, no, no,
because
no,
I
no,
was taught it
no,
was a
no.
globe.
Because there's no other way. If it wasn't a globe, I would see the North Star off no matter where the hell I'm at. In Australia, in anywhere, it doesn't matter. And the Southern Cross can't be on three ends of the dome at the same time for the tips of South Africa, South America,
The
and
right. So if we want to talk the Southern Cross specifically, you're not seeing the Southern Cross at the same time. It's different
no,
times
they're
of the night
slightly
that they see
different.
it.
I think it's
Well, they see it at
oh
different
man.
times. Like it's not like minutes neither. If you see the Southern Cross in South America, right, and then you see it in South Africa or whatever, their hours different. It's
Yeah,
not you're not seeing them at
it's
the
still
same
15.
time.
Because also it gets really weird down there too with the degrees that the constellations are rotating. That it's 15 degrees per hour. It doesn't matter where you're at. That's the speed of it. Like that's oh shit. I think I unplugged myself here. Oh, I'm fine. Oh, yeah, okay. You're on Antarctica, which is a giant ice wall. The time it would take for the constellations to come around to back to South Africa is a much bigger number because of the distance that it would have to travel. It would be moving faster, I guess, if
Yes.
you're
Okay.
watching it from
So
Australia.
would the sun in the low past the equator, right, move faster than it does in the north above above the equator,
No, because we're still
right?
spinning at the same rate. The ball is still
That
spinning at
that
the
would be a
same rate.
question for an observation to find out, right? Like
Wait.
standing on the equator, right? You can measure
Yes.
the arc of the sun 15 degrees per hour equator. If I'm at the north, if I'm in the north and I'm still seeing, you know,
It'd be
does it
lower
move
in the
at 15
sky.
degrees per hour? Is it different? And it's different for different times of the year because the sun traveling between the tropic Capricorn and tropic Cancer is different. Different rates, right? Does it travel differently Tropic of Capricorn than it does at the Tropic of Cancer, right? Because that goes back to the circle thing that I was talking about, a larger circle and a bigger circle, right? It would have to travel at a slightly faster speed of Capricorn or whatever.
No, it
right?
would only have to
The
travel at a
southern.
slightly faster speed if it was hanging above. If the sun was moving itself, that's the only time it would travel on a faster speed. But the sun isn't moving. It's constantly at 15 degrees per hour across the sky.
Well, how can we verify that? How can we verify that, right? How can we verify that it's moving at 15 degrees or if it's moving at 16 degrees per hour down in the south?
It might be in the sky longer in the wintertime. If it's winter up here, somewhere down there, it might be in the sky longer, but it's still moving across the sky, and that's because of the tilt. But it's still moving at the same speed because we're still spinning at the same speed.
Well, again, you say the tilt, but that's the narrative that you're given, and you can't prove that the Earth tilts because you can't show me that. Even so-called pictures from space don't show no tilt.
What do you? Well, no, the constellations are what show us the tilt because we could see
Right,
certain
but
ones.
right, because you're starting from the point of view that the Earth is rotating and not the sky.
Not
If
the
the
sky.
sky's the thing that's
And
rotating,
I'm literally watching because I'm
Earth,
literally watching.
everything is backwards.
What do you mean everything? What?
The Earth is not rotating; the sky is rotating. That makes it backwards, right? That's the opposite of what the narrative is. The narrative is that the Earth rotates and the sky,
Oh yeah, the sky's not some
right?
thing.
Earth
The
rotates.
stars
That's
aren't
why we
just a
see the
thing
sky
in the
rotating.
sky.
What if it's just the sky rotating the Earth?
If it was just the sky rotating and not the Earth, then we wouldn't have things like Venus, Jupiter, all these other planets moving at different speeds in the sky. That
No,
wouldn't
because we
happen
see
if
them
it was all just one thing with lights.
We see them over
Why
and
are
over
they
again
special?
and not different
Yes, they know because they don't move just like
because
they
they're
don't.
rotating in the sky.
So they aren't attached to the firmament. Venus, Jupiter, Saturn,
No, they're
Mercury.
the firmament. So there's different opinions on that, right? Does it move or
But
does
why
the
is there different
stars in the
opinions for flat
firmament?
Earth when there's one
Because
perfect model that works for the globe?
there's different opinions on the flat Earth because we haven't been doing the same thing, for 200 2,500 years or whatever. We're
Well, no,
discovering
because
things
you say
now,
that's
so
how it
people
started.
have different opinions.
So
You
see
start
now,
with
because then we're
a globe
regressing.
model.
No,
No, what I'm saying is your starting point is the globe model.
no, our starting point is it was flat. Way back when we thought the skies would move. We thought, and then
Yeah,
we
so
as humans
they
have progressed to be where
they
we are
originally
today.
thought the sky moved, and that changed with the heliocentric model that came out of the Catholic Church, and now everybody believes that it's the Earth that moves as opposed
It
to the
wasn't
sky.
just the
So
Catholic
they used
Church,
to
though. It
believe that
wasn't.
the Big Bang, the heliocentric model, it all came out of the Catholic Church.
Yes, but the people thinking the Earth was round came much before like Catholicism was like a main thing.
Well, but that wouldn't be heliocentrism. That would be centric. That would be geocentrism. So
Yeah, and even in
some
geocentrism,
flat
they
earthers
thought the Earth was a sphere. It just everything rotated around us.
yeah, I know. So that's not heliocentrism. So the sun is no longer for geocentrism. The Earth, the ball Earth,
is the center. The heliocentrism from the sun is the center, which isn't even true anyway,
So-
because the sun isn't the center either. The sun is at the center of our solar system, sure.
Yeah. Right. So, and nothing else really matters outside of that, but
A lot of stuff matters. That's how we
no, I'm
figured
saying,
out
I'm
how
saying in
we got the
relative to,
elements
in
to
relative to the
make
Earth
the Earth. That's
moving,
how.
in relative to the Earth moving, though, it's only either the Earth is at the center or the sun is at the center.
Yeah,
Of the sun, moon, and
I
star.
guess. Or
the
if you're
solar.
talking relative to the moon is rotating around the
If
Earth.
we're talking just that system, right? But anyway, so
We have an example of this that we can see, tangible. Jupiter. We see its moons. We watch the moon's orbit. We watch.
That's what I'm saying. You call them moons because you were told they were.
No,
moons.
we could see the moons. No. I've seen them with a telescope. With my own eyes.
What makes it a moon?
It's a planet. It's a small type of planet that orbits around a bigger thing. It'll disappear. You can watch it go behind it. I just shared a video where we can see Saturn.
Yeah, I understand. I understand that's what it is
from behind the moon. But there's no trickery. There's no NASA in that. That's just a telescope. That's just like
I know. I'm just saying your starting point is Earth, right? And so you see everything from that starting going forward, right? So you're gonna see this. You're gonna see the stars rotate from the starting point of it's a ball Earth. You see everything through the lens of it's a ball Earth first.
yes.
Then that's how you interpret. That's how you interpret everything around you. What I'm saying is take all that away, and prove the Earth is a ball without all that.
Yes, and I'm telling you, I know you keep coming up and telling me Georgia, but I'm telling you, if you go to the shore right now, boats will disappear and you cannot bring them back. The sun will set and you cannot bring it back. It's just the way it is. There's no bringing the sun back once it sets.
It doesn't make that doesn't give me anything tangible for the Earth, so I can measure or anything. That's what I'm saying. You can talk about the sun setting behind the curvature of the Earth.
Okay.
You can talk about all that, but it's not going to give me anything tangible to measure the Earth.
So okay, you want to Magellan it, all right? You want to Magellan it. You want to let's go right now from Alaska and walk across to Russia, wait for that Bering Strait to freeze, and go across and come all the way back around to Alaska. Tangible. Walk around the whole Earth, come back to where you start.
Yeah, what would that do?
What do you mean? What would that do? If you follow no, because it's just same thing with the sun. If the sun's always turning, I forget which way you guys say it over the flat Earth, but it would always be going right. Also, with gravity, there's nothing that explains what is moving the sun and the moon on your model. Why are they floating up there?
Electromagnetism shows that.
Then why can't we can detect electromagnetism though? We have different devices to detect measure electromagnetism.
You can measure the electric field in everything we do.
100%, but it's not strong enough to levitate a sun.
Well, that's because you're basing that comment on the assumption of what they tell you the sun is.
Prove to me right now. Measure the electromagnetism for me. Actually, you know what? I want to see that. I want you to measure the electromagnetism on everything, and don't just tell me you're taking your word for it. Someone else's word for it.
No, you can measure. I don't have the equipment to measure that, but you have the equipment that you can use to actually physically measure that. You can see that at the ground level, the voltage are different than at 100 feet up.
But
I don't have the equipment to do that.
But that's the same thing with radar and that's
a physical thing.
So is a ring laser gyroscope that detects the movement, like the 15-degree spin. That is the equipment, but it's you can't accept one and not accept the other.
No, what you're saying is detecting the 15-degree spin of the Earth. I'm saying it's detecting the 15-degree rotation of the sky.
But why
It's
would
just
we be
this.
detecting the rotation of the sky if we have the gyro right here on the ground? We set it
What's the
here.
fixed reference frame scope to begin with?
So why is it picking up the spin of the sky though? That's what I don't get. Why would you decide that's still? Why isn't it
Well,
picking
so
up the spin of the helicopter blades over there? Why isn't it picking up the spin of that car's tires? Why did it choose to pick up the spin of the sky instead of sit? When you set a gyro, okay, it's now moving in its own inertial reference frame. It's staying still while we spin around it. Like, but you connecting it to the sky is just a leap.
yeah. So okay, what's the rate of curvature? Laser ring laser gyroscope. What's the rate of curvature for the Earth?
I have no idea.
Okay, but that doesn't test anything for the Earth. Is what I'm saying. It doesn't test. It doesn't test what I can see. How far I can see
Okay,
on the
but
Earth.
it confirms that we see the sun. From our perspective, it looks like it's moving. My ear pod's about to die. Great. It
Yeah,
looks
the
like it's
sun
moving
moves. Yeah,
across.
the sun moves in the circuit
It
around.
looks like it's moving across a 15, just like the constellations are spinning around at 15 degrees an hour.
Yeah, the sun,
And then
the
when you
moon,
go
and
to
the
the
stars
South Pole,
all move.
they all rotate the opposite way. And I'm gonna. So my
You lost my
AirPods are about
phone.
to die. I'm probably gonna have to go up here and let them charge. I gotta get to bed for work anyway. But I'm gonna
Yeah.
rewatch the video when I wake up. I want to rewatch his send it to me in the message so I can watch that, the one where he explains the spin. But I do want to check it out, and if it looks legitimate, I'll be like, oh
The
shit,
star
okay, he
thing.
just figured a way. Yeah, he just figured a way to show that
So in
them
that
rotating
one
counterclockwise in the
video,
north and clockwise in the south.
yeah, in that one video, it doesn't show like his model and stuff. You have to go back to like you watch the different video to see his model. Okay, and then now you have the. If I was to just pull that out, this works, you wouldn't even understand it because you don't understand the model. You would can look at the progress of what he's done, right, to understand it. Like if I was just if somebody just showed me that video, I would be like, okay, I don't understand it because I don't see what he's doing in the video. It's just a dark video, and you got lights moving different directions. But how did he do that? You would have to go back and watch, 10 videos or something to see how he built the little
But it shouldn't have
model.
to do that because it should just make sense on what we
No,
observe
I know, but
in reality.
you have to explain everything, every detail of what he's done. It takes hours and hours to do. So
But but that doesn't work because
to
all
understand
you
it,
have
you'd
to
have
do
to
to
follow
explain it on a
along.
globe is you just look from the North Pole, you see the stars rotate one way, and when you're on the globe, you're spinning the same way, but the sky is spinning the other way because you're looking at it from a different perspective. There's so if that were to work on a flat Earth, it shouldn't take any hours of explanation. It should just be
No,
you
his
put a
model
dome.
does. His
Okay, but
does because
look,
it
so
was a process.
I put a dome right here and I'm spinning it. It doesn't matter where I'm standing in this little dome. The spin is still going in the same direction. There's no way you get to spin the reverse. It's impossible.
Yeah, I know. You're saying the dome is spinning. The dome is not spinning. The sun, moon, and stars are, and it's a lensing effect that you get when you're at a different angle of the
And that's the
of the
assumption
lens.
that there is a light outside of it, I guess, or inside of it, that there is a
Maybe
lensing
inside
effect.
of it,
But
or
there's
yeah.
never been any proof of that. So you can't use that. You can't say that it works like this if you can. Fine. I'm gonna get up. I'm gonna go to bed. I do want to continue this in a moment.
Yeah, we'll have to see when we can get another time. I mean, hey, I enjoy it. I mean, just talking because
Yeah, because
bringing things to light or whatever. But
it makes me
I'll
think.
still
It makes me think.
challenge you on this. What is tangible? Hey, check out this YouTube J Tolan Media 1, and I'll send you the link. And
Yes,
I don't know. I've been typing on the maybe it's a streaming YouTube thing that's not letting me post a comment, but in Facebook it lets me post a comment. But I'm trying to transition over to YouTube. But anyway, I'll send you a guy's link. Okay.
Yeah, and I'll check it out.
J21, and he has infrared photography done, and he has one where it because it removes the atmosphere, right? Infrared does, and he has one that you can see the Rocky Mountains from almost like Michigan.
No, I know, and I've heard of that too. I'll definitely look into it because that's a problem. I'll agree, that's a problem. But you're now putting your faith in this guy. This isn't something that you've done. This isn't something that's. But I'll check it out. I'll check it out. All right.
Yeah, I mean, you choose what you want to believe, right? And who you want to believe. All I'm saying is he does videos with infrared, but it removes the atmospheric refraction and all the other stuff that might be there. But yeah, I mean, I work a 5-day on, 4-day off schedule, so I'm off for 4 days right now.
Nice.
So I don't have to wake up. I don't have to go. Yeah.
All right.
Hey, appreciate you.
Yeah, no problem, man. Take it easy. Maybe we'll talk tomorrow.
Yeah, I'll text you.
All right.
I'll text you on the messenger.
All right, sounds good. Have a good one.
All right, brother. Take it easy.
You too. Later.
Bye.